All of these forms actually influence the potassium supplying capacity of the soil and nutrition to the crop. Therefore, understanding the interrelationship between these forms may be helpful to formulate a better fertilizer recommendation. And it may also help to improve the potassium use efficiency for crops. And with this in mind, the objective of my study was to establish a relationship between different forms of potassium under varying levels of soil fertility in molysols. Coming to the materials and methods section, so this study was actually conducted, this was a field experiment which was actually conducted during Kharif of 2022 at Norman E. Borlaug Crop Research Center at GBPOAT Pantnagar. And this was actually part of the study. And the main study was to develop fertilizer prescription equations using soil test crop response approach for test crop wheat variety UP 2855. And for under this study, initially an artificial soil fertility gradient was established. And this establishment of fertility gradient was actually necessary because it is a prerequisite to formulate these fertilizer prescription equations for the test crop. And here, actually, the field was divided into three different plots, where equally sized plots, and where the first plot did not receive any fertilizer, while the second plot received 100 kg each of nitrogen, phosphorus, and potassium, respectively, while the third plot received 200 kg of the given nutrients. And thereafter, an exhaust crop wheat, exhaust crop sorghum variety Pant Chari 6 was grown over it. And after the establishment of soil fertility gradient, we moved towards the next stage, that was the test crop experiment. And there each plot was then further redivided into 24 subplots, and this was all done under the plan which was outlined by AICRP on STCR, that is soil test crop response. So here, when each plot was divided into 24 plots, so we in total had 72 plots. And from all these 72 plots, we collected composite soil samples before before growing the test crop and the application of fertilizers. Thereafter, we analyzed or determined these different forms of potassium in the initial soil samples. Then we tried to find the correlation between these different forms of potassium. Coming to the results and discussion, so as it can be observed that considering the 72 plots, that is overall correlation, there was a very highly significant correlation which was notable under these different forms of potassium, that is water-soluble potassium, available potassium, exchangeable potassium, and non-exchangeable potassium. However, while we when we considered the correlation at different soil fertility levels, it was notable that correlation at low fertility showed there was highly significant correlation at low fertility among the different forms of potassium, while in case of medium and higher fertility, mostly it was observed that highly significant correlation was noted with water between available potassium and between available potassium and exchangeable and water soluble potassium. However, with non-exchangeable potassium, although the correlation was positive, but it was not found to be significant. Actually, this study was conducted because when in STCR we formulate a fertilizer prescription equation, we require certain basic parameters to formulate these equations. And these parameters includes efficiency of fertilizers, organic manures, and soils. And sometimes it is observed that the contribution or the efficiency of potassium in while determining these basic parameters comes near 100% or beyond 100%. So there is something that is actually replenishing the solution pool. And it is through previous studies actually observed that it may be because of the priming effect caused by higher doses of nitrogen and phosphorus, or it may be also because there are different forms of potassium that are actually replenishing the readily available pool. For this, the study was conducted. And afterwards, if we are able to consider the contribution of non-exchangeable potassium as well, which is showing a highly significant correlation when we are considering the overall plots, there may be a chance to develop a better fertilizer recommendations and improve potassium use efficiency. Finally, to conclude my study, I can suggest that in general, there is a dynamic equilibrium that is existing between these different forms of potassium in soil, and this may indicate their indispensity in soil. However, since this was only a 1-year trial, so there may be a need to consider more studies with more soil types and crops to validate this study. Thank you. Thank you.
Madam, because it is completely a field experiment, I believe.
Yes, ma'am.
Parallelly, pot culture would have been done because whatever we are taking the sample from a field, it is maybe may not be so homogeneous or representing to a greater extent. So parallelly, if it has been run through a pot culture, I think we could have some a comparison base
Yes.
for these correlations and all which are developed from a field
Yes,
soil.
ma'am. That may be a future prospect with this to conduct a pot experiment.
From field, initially we'll start with the pot and then we will extend to the field in
Yes.
such type of studies which require more minute and very accurate results.
Yes, ma'am. That
Whether
may
it
be
was done, whether it was done or directly it was done at the field level.
Ma'am, it is actually done at the field level right now. No, we have not conducted a pot experiment with this.
Because it will be at a larger level when you take from a field. It could be a larger level, of course. But we would have cross check when parallelly pot culture has been run for such type of experiments, I believe.
Yes, ma'am. That could be a potential forward regarding this study.
Based on this, like for high fertility, medium fertility, and low fertility soil samples you have taken. So, could you have some recommendation like which crops would be better based on this soil type and so on?
Ma'am, actually, this study is specifically done for under test crop wheat. So I can recommend it that for cereal crops we can go for this. However, we can there is also found under legumes. Sometimes these efficiencies or contributions comes higher for nitrogen as well. That may be because of biological nitrogen fixation. So that can also be conducted for legumes as well in future.
I mean, potassium responsive crops or whatever are there. Because as you have given for low fertility and all, based on that, we can at least say that these crops which require high potassium requirement and so, and we can save even some of the fertilizer. So based on this studies also.
Yes, ma'am. Actually, ma'am, STCR aims to reduce the usage of fertilizer, or in other words, save fertilizer, because it is its main emphasis is towards site specificity, towards precision farming, because we are considering both soil testing and crop response here. So I have done my MSc work in soil test crop response as well. So there is some form of fertilizer saving that we have observed in our studies.
In general, what do you think that this type of studies, mostly they are restricted at the research level, but to make them available for the farmer and in a more understandable way, they must be taken to the farmers also.
Yes, ma'am. Actually, some of the whatever the fertilizer prescriptions that we have developed, these are also utilized under online recommendation systems, and right now they are also going towards applications and softwares to get more in reach with farmers.
From my side, because basically here it is hardly correlation and all. So as you have told, in future different crops which are I mean fitting into this particular this could be also focused.
Yes, ma'am.
So what percentage of the soils in your area generally they are under low fertile and medium fertile and high fertile with respect to potassium?
Ma'am, that I have right now I have not the
No,
relevant information.
you have taken this study.
Ma'am, actually, we when developed the soil test crop response, there are two approaches, inductive and deductive approach. So we undergo the deductive approach. So we create the different levels of soil fertility in the field only.
But
So
when we have an idea, like in Telangana, we say this much percentage of the soils are low in fertility with respect to this medium and high fertility, then only we can say that this is relevant to the farmers, isn't it? When we know the real percentage of the soil distribution, that will be directly going to the farmers. Yes, in these areas with high fertility, in these districts with low fertility, this recommendation could be going direct. Although you have created that fertility level, but how it is pertinent to the state level or state soils, your area soils, it is more important. The percentage of the soils which are falling under low, fertile, medium, high, isn't it? Taking that into base only, you have done this study. So that it is directly useful to the farmers with this particular fertility gradient with respect to potassium. Yes or no?
yes, ma'am. Okay, ma'am. I will consider the your.
4 point why I am saying is when you are presenting in your future presentations, you must say in our area with this percentage of low fertile, medium fertile, we have taken that into target and we have done for the in this study. So that should be the base.
Okay, ma'am. Okay, ma'am.
So any more queries from the audience and others can be kindly pushed in.
Share your nice presentation in potassium levels, different level studies in potassium levels. But even what's the initial status of potassium in whatever conducted research?
So initially, the potassium levels in my study were under medium category.
Medium level, okay. But you can whatever you can after harvest you can have to any estimate. You have to any shifted to medium to any range for the higher road to higher levels.
Sir, I'm currently conducting the analysis for that, and I have also planned to find, to determine these different forms under the post-harvest soils as well.
Okay, nice. Okay, all the best.
Thank you, sir.
Nice presentation.
Thank you, sir.
Yes,
I think we can take the next participant. So Dhanishri ma'am, are you there?
Next presenter, sir, please.
Dhanishri ma'am, are you there?
This is Ajay, sir.
I think Dhanishri ma'am will be next.
Okay, sir.
I think she could once switch off and log in again, Dhananjay.
Okay, ma'am.
Yeah, Madam Dhanashri, your I think screen sharing has started. Yes. It's visible, Madam. You can go ahead, Dhanashri, Madam.
विजिबल जी ठीक
Ma'am, you are not audible.
तो है शुरू करो Start with
You can start, ma'am.
Yes, you can go for slide mode, presentation mode. Dhanashree, please go for presentation mode.
Yes, please, Dhanashree, your slide is visible, but voice is not audible, please.
I think there can be a technical issue like internet connection is weak. So I think we can move with next participant. Oh, Dhanashree ma'am, are you there? Ma'am? I think we can move with the next participant. Mr. Ajay, are you there, sir?
Yeah, sir, I am ready, sir.
Okay. Just making a co-host, then we can start this.
Sir, may I share my slide?
Mr. Ajay, are you there, sir?
Yeah, sir, I am here. I can share my.
Oh, yeah, yes, sir, yes.
ಮನೆ ಕೆಲಸ ಎಂತ ಆಗ್ತೈತಿ
Sorry, sir.
ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಸುಮ್ಮನೆ ಹಂಗೆ ಔಟ್ ಸೈಡ್ ನೋಡಿದೆ ಕಿಲೋ ಆಗ್ತೈತೆ ಪ್ಲಾನ್ಸ್
Here you can share your screen.
Just a minute, sir. Sir, am I audible?
Yes, sir. It's visible, sir. Screen is visible. Can you go for like PPT mode or like zoom in?
Just a second. Okay, it's visible for everyone.
Visible, you can go for presentation mode, Mr. Ajay.
Yeah, sir.
Okay.
So my name is Himanshu Prakash. I am from the University of Tamil Nadu Agriculture University. So I am a PhD scholar in the Department of Remote Sensing. My research is unlocking of Tiruvallur hydrological resource and mapping of groundwater potential by integrating the remote sensing engines for implementing the conservation of agriculture strategy. So as you know, the South India, Chennai is the highly metropolitan city. Next to the Chennai, Tiruvallur is the going to be upcoming the highly populated populated city. So my research is conducted in the Tiruvallur region. In Tiruvallur, let me show. So in Tiruvallur, we generated the groundwater potential. For generating of groundwater potential, I taken the different types of data. So firstly, I taken the digital elevation model and Landsat 8 and 9 and rainfall data and soil data. So from the digital elevation model, I taken the surface. From the surface, I taken the slope. And also I taken the hydrological data. From the hydrological data, I driven the drainage density. And from the Landsat 8, I just calculated the land use land cover and also I taken the rainfall data and the soil data. So all the data are reclassified and I just put on the this weightage overlay. So this weightage overlay is nothing but we have to set the parameters for the groundwater potential. So according to the data what I feed. So the final output of the groundwater potential you can see from the map. So from the LULC you can see the so the LULC you can see that the red color are settlements and the white color are the water prone area and the yellow color are the agriculture and some barren lands are being classified in the LULC. So you can see the groundwater potential here. So when there is the water body, so here the water body is located. So due to the water body, the groundwater potential is very excellent in the region which is located near to the water body. So if you see through here, so the near to the agricultural land and some of the settlement, so there is a very minimum of groundwater potential zones. Not only I generated groundwater potential zone, what are the drought risk zones? So you can see here during the summertime we also facing the drought. So this drought may cause some serious effect in the agriculture. So those zones also detected during the rainy season. We will cause flood. So what are the flood risk zones also generated? And from my conclusion, the excellent source of potential zones are around 0.1647 area of square kilometer, which is been found in the groundwater potential zones. Hello, sir. Sir.
Yes, sir. Keep. Yes, sir. Keep doing, sir.
Yes. Yeah, sir. Completed, sir.
A nice presentation, Ajay. But you
Yes,
have
sir.
studies in groundwater studies potential.
Yes, sir. Yes,
Hello,
sir.
are you hearing?
Can you repeat once again, sir? Sir, your voice, what? Hello, sir. Your voice is not audible.
Yeah. Mr. Ajay,
Yes, sir. Yes, ma'am.
I wanted to just ask, because many of the remote sensing and GIS studies, they will be giving lot of data and all. But practically, what is the practical utility of this to a particular area and all? Could you throw some light on that?
Ma'am, why I taken this particular area? Because as you know, the South India highly populated city is Chennai. Next to the Chennai, Tiruvallur is going to be a next highest population. So that's why I taken this area. So this region, as you see in this region of the taken groundwater potential is highly populated, which is highly populated. There is more settlements are there. So when I was doing this research, so I get the groundwater potential is not going down. It's just increasing each year according to my validation, and also I taken some data from the Center of Groundwater Board, which shows it's a good water zones in the region of Tiruvallur. That's why I taken the Tiruvallur map.
You are worked in watershed area or you can general parts of the taken studies on groundwater
Sir,
studies?
actually my MSc work is related to methane emission in the rice field, sir. So
yes.
this is my extra. I did my own interest. That's why I generated this one, sir.
This result or something, whatever you have analyzed, it is passed on to the particular department where it could be used for the future needs and all. Then only it has some essence.
Yeah,
Otherwise,
ma'am, of course.
otherwise it will be there in only article or journal. it will be just seen by the scholarly people.
Yes, ma'am. I agree with your statement.
Otherwise, some practical utility, if it is there, means it should go to the relevant department where it could be used.
Yes, ma'am. Yes, ma'am. Actually, upcoming, one of my colleague is doing this research, so I think it will maybe helpful for him and also for the room.
Even the people from such department could be involved in the advisory committee such that they are aware about these results and work which is going on.
Yes, ma'am. Yes, ma'am.
Okay. So the study is good, but it should have its relevance going to the correct spot where it is required.
Okay. Please, next presenter.
Your screen is visible, ma'am.
Yes,
You
yes,
could
visible.
kindly speak out so that audio we can go ahead. Please.
Dhanushree, please go ahead.
Are you able to hear us, Dhanashree Bharat? Because you are just going to see whether it is displayed or not. If you are able to hear us, please go ahead with the presentation.
Is there a network issue, madam?
Yeah, because I just don't know whether it is visible to her or not, but we are able to see it.
Dhanashree Bharat, please.
No, ma'am, you're not audible. Actually, Dhanashree, ma'am messaged me. No, ma'am, you're not audible. No, ma'am, no, ma'am.
If she sees
Okay.
the chat box, she will know that our response.
Yeah, yes, madam.
Yes, sir. Before also we have given that slide.
Rohit, you can go for next presentation. Better.
Okay, so next presenter will be Mansi, ma'am. Are you there? I'll make you co-host. It's Mansi, I think. Yeah, Mansi Sharma.
Yeah, Mansi, yes.
Is my screen visible?
Yes, yes, yes.
Visible.
Yes, 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 visible, visible. Go ahead, Mansi.
Good morning, everyone. My name is Mansi Sharma. I have recently completed my bachelor's in BSc Honours Horticulture from Punjab Agricultural University. The title of my poster presentation is Recent Biotechnological Advances and Ethylene Management Strategies for Horticultural Crops. As it was also mentioned by our respected chief guest, Dr. Sanjay Kumar, and the inaugural session, that how 30 to 50% of the commodities are lost as post-harvest losses, and not much advances are made to control these post-harvest losses. First of all, we all know that ethylene is a ripening hormone, and this hormone is responsible for most of the post-harvest losses. So how this hormone is produced, as you all can see from the chart, that L-methionine is the precursor of ethylene that is further changed into SAM and MTA through SAM synthase. This SAM is further changed into ACC, that is also known as aminocyclopropane. And this ACC is lastly changed into the end product ethylene with the help of ACC oxidase. So this is how ethylene is produced. Now, till date, people are only relying on traditional approaches, like they are using ethylene scavengers or methyl cyclopropene or potassium permanganate. And the rest of the people are even also relying on the controlled atmospheric storage, in which what they are basically doing is they are reducing the oxygen level, and they are increasing the carbon dioxide level. But all these approaches are not that fruitful. Still, losses occur. So what can be done is we can take the help of the biotechnological tools to control the ethylene levels in the post-harvest sector. So there are three genes, that is SAM hydrolase, SAM decarboxylase, and ACC deaminase, which are reported to control the ethylene levels. SAM hydrolase and SAM decarboxylase are found in the bacteriophage, and with the help of the cauliflower mosaic virus, which is a very common vector that is utilized in the recombinant DNA technology. This gene can be introduced into the desirable host with the help of the gene gun or Agrobacterium tumefaciens. whereas ACC deaminase is found in the bacteria Pseudomonas chlorophyll, and not only it reduces the ethylene level, but it is also found to protect the plants from the heavy metals and floods. Apart from it, use of the antisense RNA technology can be made, in which complementary antisense mRNA of ACC synthase and ACC oxidase can be made, which will inhibit the translation and ultimately control the ethylene production. So some results of the findings are when ACC deaminase from bacteria, that is Pseudomonas chlorophyll, was introduced into the tomato plant using CAM, that is cauliflower mosaic virus, as the promoter, so ethylene levels drastically reduced by 90%. Similarly, in broccoli also, when ACC oxidase was used in the antisense orientation using the antisense RNA technology, the levels of the ethylene reduced by 91% after 90 hours. It is also tried in one flower crop, that is carnation, and using MAC as the promoter, and the results were very good, and the ethylene level decreased by 90%. So, in conclusion, incorporating biotechnology in the post-harvest sector can revolutionize how food is being processed, stored, and distributed. It can increase the shelf life and promote sustainability.
Yeah, madam, it is based on a review, but you have done something in these lines.
No, ma'am, it is based on the review paper.
अच्छा, ये रिव्यू है आपका, है ना?
Yes, sir. Yes, sir.
तो आप अभी क्या वहाँ पोस्ट ग्रेजुएशन कर रहे हैं, पीएचडी कर रहे हैं?
No, sir. I have just recently completed my bachelor's from there.
Okay. So I think your poster is completely white and blue. Huh? You had a color code or what?
No, ma'am.
Could you throw some light, like how, what is the percentage of, what is the improvement in the, what you say, yields or reduction in this particular losses with respect to this particular technology?
Ma'am, this technology is basically tried only by a few of the scientists, and that is only tried in few crops, that is tomato, potato, and carnation only. The results were very fruitful as compared to the ethylene scavengers or potassium permanganate methods. Those methods are not that effective. When we are using ethylene scavengers or sachets, still losses occur, and most of the commodities, even now till date also, as it was mentioned by Dr. Sanjay Kumar sir, that not much advances are made in the post-harvest sector. Although biotechnological approaches are used in the other sectors, but till date it is not used to control the ethylene levels.
बहुत बढ़िया, बहुत बढ़िया। ग्रेजुएशन लेवल पे तो एक बहुत अच्छा एफर्ट मुझे लगा। अभी ग्रेजुएशन में आप हैं। हेलो।
यस सर।
हाँ, बढ़िया एफर्ट है। इसी तरीके से जो है, ये बताओगे जरा एथाइलिन क्या है? ये जो एथाइलिन आपने मेंशन किया, ये है क्या? इसका फंक्शन क्या है? एक कोई फंक्शन बताएंगे इसका?
सर, राइपनिंग हार्मोन ये गैसियस हार्मोन है। जब फ्रूट्स में जब पेड़ मतलब ट्री के साथ अटैच होते हैं तब भी ये हार्मोन प्रोड्यूस होता है, और उसके बाद जब डिटैच हो जाते हैं तब भी ये हार्मोन प्रोड्यूस होता रहता है, जिसकी वजह से जो गैस होती है इसकी, वो जब बढ़ती जाती है तो उसकी वजह से फ्रूट्स जो है डिटीरियोरेट करने स्टार्ट हो जाते हैं, ट्रांसपोर्टेशन में आधे से ज्यादा खराब हो जाते हैं, जिसकी वजह से लॉसेस बहुत ज्यादा होते हैं और वो कंज्यूमर्स के पास नहीं पहुंच पाते।
बहुत बढ़िया, बहुत बेहतरीन। आगे का क्या प्लान है?
सर, आई वांट टू परस्यू मास्टर्स इन प्लांट ब्रीडिंग इन जेनेटिक्स।
अच्छा, प्लांट ब्रीडिंग इन जेनेटिक्स में।
यस सर।
ठीक, बहुत बढ़िया, बहुत ही बेहतरीन, बहुत अच्छा। रोहित जी, थोड़ा सा आप जो है, भले ही आपको 30 सेकंड कम करना पड़े लोगों का, या 1 मिनट, क्योंकि 3:30 बजे वैलिडिटी कराना है 3:30 पे, तो उसका भी ध्यान रखिएगा।
जी सर।
और मैं अपने चेयरमैन जो है भानुरेखा मैडम और अशोक साहब से भी कहना चाहूंगा कि 3:30 पे वैलिडिटी कराना है, तो थोड़ा सा इसको अपन क्रिस्प करके चलें, आपसे आग्रह है मेरा।
ओके सर जी, ओके सर जी।
ठीक है, बहुत बढ़िया मानसी, बहुत अच्छा किया, बहुत बढ़िया। नेक्स्ट
प्लीज, नेक्स्ट प्रेजेंटर।
Hello, ma'am. Am I audible?
Yes, ma'am.
Yes, madam. Yes, madam.
Yes, madam. Please go ahead, Dhanashree Bhatt.
Sir, thank you, sir. A very good morning, everyone. My name is Dr. Dhanashree Bharat Jadhav, Assistant Professor, Department of Agronomy, Lovely Professional University, Punjab. Today, I am here to present the poster on effect of biomanuring on morphoqualitative traits of organic cotton. So, all of you are very well known about the cotton. So cotton is a soft stable fiber that grows in a bowl or a protective case around the seed, belongs to the genus Gossypium in the mallow family Malvaceae. Also, it is popularly known as white gold and king of fiber. Basically, my experiment was on organic cotton. So the production of organic cotton was 343 lakh bales with the productivity of 501 kg per hectare under an area of 12.56 million hectare during the year of 2019. A field experiment was carried out during the Kharif season of 2019-20 and 2020-21 at Center for Organic Agricultural Research and Training, Department of Agronomy, Dr. Panjabrao Deshmukh, Krishi Vidyapeeth, Akola, Maharashtra. In this experiment, there were 9 different treatments used to check the effect of morpho-qualitative traits of organic cotton under rain-fed conditions. In the treatment, there was solid manures as well as the liquid biopreparations. For example, Jivamrut, cow dung slurry, vermiwash, which was applied at the rate of 10% in 4 equal splits at 20, 40, 60 and 80 days after sowing by adopting a method of drenching, as well as the soil manures like compost, neem cake, vermicompost applied directly to the soil at 20, 40, 60 and 80 days after sowing. Okay, so then moving to the results. So the results of the experiment were showed that in growth parameters of organic cotton, for example, plant height, number of functional leaves per plant, leaf area per plant, number of sympodial branches per plant, number of squares, number of green bolls and total diameter accumulation of plant was recorded significantly higher with a combined application of vermiwash applied at the rate of 10% and soil application of compost at 3 tons per hectare and neem cake applied at the rate of 500 kg per hectare. So the treatment, that is T6, was found at par with combined application of cow dung slurry with compost and neem cake, also with the alone application of compost at the rate of 10 ton per hectare during the both consecutive years of experiment. In case of yield parameters, the number of picked bolls per plant and seed cotton yield per plant show a significant difference among the 9 different treatments. The number of picked bolls per plant was 26.37 and 22 during 2019-20 and 2020-21 respectively. Also, the seed cotton yield per plant was 66.64 and 54.91 grams during the both years of field experiments. The treatment number 5, 7 and 3 was registered at par value with a combined application of vermiwash with compost, neem cake, except in the year of 2020-21 in seed cotton yield per plant. The average boll weight in grams was not reached to the level of significance during the both consecutive years of the experimentations. Okay, so the next, the yield data like seed cotton yield, lint yield, stalk yield and biological yield in kg per hectare were also showed the similar trend like yield parameters. When compared with both the field experiment, the first year data of the trial noted the highest values of all growth, yield parameters and yield also. In case of the quality parameters like ginning percentage, seed index, lint index, oil and protein content were found non-significant. Also, the fiber quality parameters, namely 2.5% of the staple length, uniformity ratio, fineness micronear, bundle strength and elongation were also noted non-significant. However, the numerically higher values were recorded with a combined application of vermiwash with a compost and neem cake. So, the conclusion of my study is the combined application of vermiwash applied at the rate of 10% with soil application of compost at the rate of 3 tons per hectare with 500 kg per hectare of neem cake was found to be a best strategy for obtaining a higher yield, growth and quality of organic cotton under the rain-fed conditions of Maharashtra. Thank you.
Nice presentation, Dhanashree Bharat. Is it conducted your research in fixed plot?
Hello, sir.
This is your conducted research in fixed plot last 2 years.
Yes, sir. research was conducted at organic research station.
Okay, organic research station. But you have to manage and control, you can biomulching of Sanyam at 30 days, 35 days.
Yes, sir. This is not actually absolute control. This is a check plot. We have to
Yeah,
measure the results of biomulching of sun hemp buried at 35 days after sowing. So it is just like a popular check plot.
Okay. But you have to absolutely control is not there in treatment.
No, there is not absolute control.
Because we have to compare to seed cotton yield. That is, you have to many mention absolute control. That is very important treatment. Okay.
Yes, sir.
Any audience others, please?
Because you say it as an organic cotton. So what is the literal use of this organic cotton? Because it's not an edible crop. What do you think?
Yes, ma'am. The most trending demand for the organic cotton is based on the like a skin. It is most suitable for the allergy type of skin. It is very soft. It is non-allergic to the sensitive skins. So it is high demanding for the European countries as well as our country.
One more thing I would like to.
And also, and also, if we are growing the organic cotton, the soil benefits also we can measure.
Yeah. Apart from that, because most of the, audience may be knowing that majority of the cotton, it is used for the napkins. So in order to reduce the incidence of this cervical cancer and all other countries, well-developed countries, they are in demand of this organic cotton also. It is one of the prime use of this organic cotton, please, Dhanush.
Yes, ma'am.
Yeah, that is what they are aiming at. And if we could tap that market potential, it would be useful to the farmer.
Yes, sir. Ma'am, now in the year of 2020-21, India is ranking first for the producing of organic cotton.
Is it any separate market, organic cotton market price is any separate, Dhanushri?
In India, there is no any like a separate market for organic because there is no any separate MSP for the organic or the traditional cotton. So there is no any like nowadays there is no any market exist.
Okay. Nice presentation. Kanga. Okay, next presentation, please.
Thank you, sir. Can I leave?
Okay.
Thank you, sir.
Mr. Shivankar, Shivashankar, are you there? Hello, Mr. Shivashankar, are you there? Mr. Shivashankar, are you there?
Yes, sir.
Yeah, we can start with you. Or proceed with you.
Yes, sir. 1 minute, sir. Sir, I'm unable to share my screen, sir.
Like you log in from 2 devices or 1 device?
Yes, sir. 2 devices.
What is the name of your laptop device which you log in?
Shivashankar.
Shivashankar, I make already co-host na Shivashankar K University of Agriculture.
Okay, sir. Let me exit from the. Yeah. Off ಮಾಡ್ರಿ. ಏನು ಮಾಡಬೇಕು? Rovana. Sir.
Yes.
Sir, please make me an host, sir.
What is the name of the device I'm asking? I'm already make you co-host like Shivashankar K University, already co-host.
You disable that one and.
Okay. Okay, your co-host now. You can share your screen, Shivashankar.
Sir, host disabled participants screen sharing need is
Now just try.
same, sir.
Same. There was some technical issue. Okay, we can go with Arpit, I think. We'll come back to Vishwa Shankar, okay? Arpit Kampoj, are you there?
Arpit Kampoj. Are you
Arpit
there, sir?
Kampoj, are you there, sir? You can
Hello,
unmute your
yes, sir.
host.
Yes, sir, I'm
you
here.
can. We can start with you.
Okay, sir. Is it visible, sir?
Yes, please, visible. Go ahead.
Okay. So, welcome esteemed colleagues and distinguished guests to the International Conference on Recent Advances in Agriculture. I am Arpit Kamboj from pre-final year in CCSHU Hisar. So, currently I am
Title is not
representing
visible. You can,
review poster.
yeah, poster
So,
also.
yeah, review poster. So today we delve into the critical facet of agriculture sustainability and post-harvest management and value addition in horticulture crops, with a focus on understanding the causes of post-harvest losses and effective management strategy. So in India, where agriculture plays a pivotal role in ensuring food security and livelihoods for the millions of farmers for optimizing the post-harvest practices. So, despite the significant advancement in production of techniques, the source of post-harvest losses continue to decrease the income of the farmers and also aggravate the food insecurity and economic instability. So, coming on the introduction, so yes, majorly the farmers or the majorly the fruits are the perishable in nature, and bulkiness render them more challenges and handle to as compared to dry grains. So this perishability coupled with limited knowledge and capital hampers the development of horticulture industry. So there are the various causes of losses. The firstly the primary causes and secondary causes. The coming on the primary causes. So firstly the primary cause is biological cause. These encompass the factors related to the inherent biological possesses the horticulture crops themselves. This includes the natural ripening, senescence, aging, and susceptibility to pests and diseases, which can lead to the spoilage and deterioration in if not managed effectively. And second one is microbiological causes. In this causes the microorganisms such as bacteria, fungi, and molds. This plays a significant role in post-harvest losses. They can proliferate rapidly in the harvested crops and leading to decay, rotting, and the formation of the various toxins that thereby reducing the quality and the market value of the produce. Third one is the physical loss. Physical damage during the harvesting is mainly due to the bad handling, and transportation is a common cause that post-harvest losses. And this is a bruising, cruising, cuts, and some of abrasions can compromise the integrity of the horticulture this produce. Fourth one is chemical causes. There is we can do to more perishable to we can exposure to the various chemicals either from the agrochemical residues, some of environmental contaminants, or improper use of post-harvest treatment can adversely affect the quality and the safety of horticulture crops. Fifth one is physiological causes. Physiological causes, mainly post-harvest physiological disorders, can arise due to the various factors such as such as improper temperature and humidity conditions, inadequate storage facilities, or and these disorders can manifest in leads to uneven ripening, chilling injury, water losses, some of excessive ethylene production that also deteriorate the quality of the produce. So coming to the understanding these are the primary causes of the post-harvest loss is the crucial for the developing target management and strategies aimed to mitigating losses. And coming on the secondary cause are losses that loads to the continue that encourage the primary cause loss, and these are usually result to the inadequate and non-assistant capital expenditures. So first one is inadequate harvesting. Second is insufficient containers to transport of perishable goods, and third one is insufficient refrigerator storage for the traditional processes, and the last one is inadequate dry equipment. So coming on the statistical analysis, India ranks second in the largest producer in the fruit in the world. So and 6.65 million hectare land, and yielding the 98.58 million metric tons according to NHB 2018. So however, the post harvest losses and waste ranging from 20 to 40% pose a significant challenge for food security, and approximately 10 to 15% fresh fruits and vegetable. And this issue the critical as the estimated 10 million people worldwide to suffer from malnutrition, hunger, and other chronic ailments. So coming on the management, so first one is improper harvesting technologies, providing harvesting practice to minimize the physical damage to crops, and such as using the sharp tools, handling produce with care, and can reduce the post-harvest loss significantly. Second comes to the enhance the storage facilities, like investing in modern storage infrastructure, including the cold storage and the control atmospheric storage, and some of the equipped warehouses, and etc. And third one is quality packaging, utilizing the quality packaging material like techniques such as modified atmosphere packaging, vacuum sealing. Yes, that helps to preserve the freshness and quality of produce. And fourth one is temperature and humidity management, maintaining the optimal temperature and humidity conditions during the storage and transportation can prevent the physiological disorder, and such as the microbial growth, moisture loss, and this also preserving the quality and marketability of horticulture crop. Coming to the fifth, post-harvest treatment, such as giving the fungicide, bactericides, and ethylene inhibitors can control the microbial growth and inhibit the ripening process and extend their shelf life. So sixth one is integrated pest management, implementing IPM strategies, including the biological control methods, crop rotation, and use of the pheromones, help to manage the pest and disease. Seventh one is value addition and processing, and marketing information system, capacity building and training, and some others are like policy support and infrastructure development. So yeah, so to conclude, there should be proper management in temperature, humidity, and effective method of preventing these losses. And processing methods are also better to gain from farmers benefits and to longer their shelf life and reducing these losses, and yes, enhancing the market opportunities. So thank you.
It is based on a review, I think so, Arpit.
Yes, ma'am. It's totally based on reviews, and I can references also. I can references of Hello View and some references I haven't given in the last of the poster. So any doubts?
You have completed your undergraduation?
Yes, I am in third year of my graduation.
Oh.
So I made some small benefit too.
Okay, definitely. Good efforts by you. Oh.
Thank you.
Oh.
Okay.
I hope we could call upon the next presenter, please.
Sure. Actually, ma'am, we have like one oral PPT is there. Sir has like election due to yesterday, so he's not able to present. So we just want to present, ma'am. So can we allow him like for 4 or 5 minutes, ma'am, please?
Sure.
Okay. So Boris sir, are you there?
Yes, I am present.
Okay. So I'm making co-host. We can like start again.
Sure.
Thank you, sir.
Can I share my screen now, sir?
Yes, sir. Please.
Okay. Is my screen audible? Visible,
It's visual,
sorry.
sir. It's visual, sir.
Okay, I'll start.
Yes, well and
Very good
audible.
afternoon. Okay, a very good afternoon, madam, and all the esteemed dignitaries as well as the participants of today's program of today's conference. I am Longzam Boris, working in KVK in Manipur, and my topic is enhancing rice productivity in Manipur by effectively controlling blast disease. On the outlay, I'm giving a brief presentation of the blast. Blast, as we all know, is a very significant disease when it comes to rice, and paddy being the major crop in Manipur. Blast is one of the most significant diseases which can effectively reduce the yield. And moreover, due to the rampant use of nitrogenous fertilizers as well as the repeated use of the particular chemical for the management of blast, the significant reduction in production as well as the reduction in efficiency of the fungicides has been very much prevalent in Manipur. And moreover, even after the significant production of some of the resistant varieties by ICR Manipur Center as well as CAU, the emergence of new pathogenic Magnaportia grigia races have rendered them ineffective in the field. And hence, we need to improvise certain new fungicide combinations in order to control blast disease in our state. The major objective of our study includes the management of blast disease and the checking of certain parameters, for example, the effect of treatments of neck blast disease as well as slip severity, and the effect of treatment on certain parameters, for example, plant height, number of effective tillers per hill, number of spikelets per panicle, 1,000 grain weight, grain yield per kg, kg per hectare, straw yield kg per hectare, and the yield increase over control. And some other economic parameters for such as benefit, cost-benefit ratio, as well as the gross return, gross return, gross cost has also been analyzed in our study. This is the brief experimental layout of my study. It was taken out during in KVK Thawal during Kharif 2022 and Kharif 2023 using the crop variety rice CAU R1. It was done using RCBD randomized complete block design with 4 treatment and 5 replications. The first treatment being seed treatment using this chemical, second using hexaconazole in this particular formulation, and third, which is the main treatment of interest, is azoxystrobin and the tebuconazole, which was spread in 3 phases at weekly interval. The first spray at the budding stage, and the treatment number 4 being the untreated control. These are the major packages of practice which was taken up during my experiment. In the first treatment, second treatment, and third treatment, we can see that most of the package of practice has been completely taken up, whether it is in case of soil treatment, fertilizer, top dressing, second top dressing, micronutrient. And when it comes to weed management, it's weeding, we use chemical petrolachlor and pyrazosulfuron ethyl, which is pre-emergent herbicide, and bisphenol sodium as the post-emergent herbicide at 2 different phases. And when it comes to insect management, apart from disease management, we took up imamectin benzoate at tillering stage. And when it comes to treatment number 4, which is the control, it is the farmer's practice, we took up almost the same managemental measures. The only difference was in case of this strict application of nitrogenous fertilizers and the potash, and as well as single superphosphate, sorry. Here in the first table, we can see the effect of the different treatment on disease incidence. Here also we can find that among all the 4 treatments, the treatment number 3, azoxystrobin and tebuconazole, was found to be slightly more effective when it comes to management of blast disease, as it is evident from the table where the disease incidence was lowest in case of treatment number 3. And the similar pattern was also found in case of AUDPC, which is area under disease progress curve. Here also we can find that the value of AUDPC was found to be the lowest in case of treatment number 3, and the highest value of yield control over local was found in the same treatment, that is treatment number 3. This is a graphical representation of the different findings of the table number 1. And here on the next table, we can find the effect of treatments on the net blast incidence as well as the lead blast severity. Here also we can find that the treatment number 3 was found to be the most effective as well as the most significant when it comes to the net blast incidence percentage. That is the percentage of net blast was found to be the lowest in case of treatment number 3, and the highest was found in case of treatment number 4, which is the local. The same pattern can be found in case of lead blast severity, which was recorded after 7 days after the last spray. Here we can find the 2.3% and 2.4% over the 2 seasons was found for the management of lead blast severity in case of treatment number 3. The next is the graphical representation of the various finding of table number 2. And in table number 3, we can find the effect of treatments on plant height. This is plant parameter. Here we can find that the treatment number 3 was found to be slightly significant, slightly higher in value when it comes to plant height across 4 different intervals. That is 20 days after sowing, 20, 30, 40 days after sowing. This is the graphical representations. And next is the economic part. Here also we can find that the number of effective tillers, number of specklets per panicle, 100
Make it fast because you have already exhausted the 5 minutes. Please
Yes,
do it fast.
Okay, madam. Sure, no problem. Here also we can find the same trend. There is the treatment number 3 was found to be effective in across all the different parameters mentioned here. In graphical representation, here also we can, when it comes to cost of cultivation, gross return, net return, as well as the benefit cost ratio, the treatment number 3 was found to be slightly significant. That is slightly better when compared to the remaining treatment. These are results when it comes to the performance extension gap, average grain yield extension gap, technology gap, as well as technology index was found to be better, improved in case of treatment number 3 compared to the remaining treatments. This is graphical representation. In conclusion, we can say that the treatment number 3, which is azoxystrobin and bucanazu, was found to be better compared to the remaining 3 treatments for controlling of blast disease inverse, provided the remaining packages of practice are followed as given by recommended by different institutions. Thank you. If anyone has any query, please feel free to ask. Thank you, ma'am.
It was a demonstration trial, isn't it?
This is demonstration trial, madam. Yes.
Then was it practiced, this particular best treatment? Is it being practiced by the farmers?
Yes, madam, it is being practiced by the farmers.
What is the percentage of, shift to this particular practice after seeing the better results?
Actually, madam, this particular practice, this is in the 2nd year trial. So right now in Thawal, for our district, Thawal district, around 70% of the farmers, they have taken up under different programs. Coverage is around 70%. So after the completion of 2nd year, maybe around 90% coverage will be there.
Oh.
Yes, ma'am.
If there are any other queries, they can be done. Otherwise, I think we can shift to the next question.
Can I which variety?
Yeah, sir. Actually, sir, this particular trial was taken up using the most popular variety of rice in Manipur, CUR1, developed by Central Agricultural University in Falsa.
Is that variety is resistant to can blast disease?
Yes, sir. The breeders they claim that it is resistant to blast, but since it has been so long, it was released. There are so many pathogenic races that can attack it. So incidences of blast has been reported all across the states.
Okay. Nice presentation, nice demonstration, farmer field. Thank you.
Okay,
Thank
sir.
you very much.
Thank you, sir. Thank you so much.
Please, next presenter.
Shankar, is there?
Yes, sir. I am here, sir.
Proceed. Share your screen.
Is it visible, sir?
Yes. Please continue.
Yes, sir. Good morning to all the delegates present here. I am Shivshankar K from the University of Agricultural Science, Dharwad. Here I am going to present my poster on sensor-based nitrogen management in maize by using green seeker and spread chlorophyll meter under varied growing conditions. As we all know, maize is the third most important cereal crop after rice and wheat, which is an exhaustive crop because of its higher nitrogen demand, uh, average amount of 150 kg and 65 kg and 65 kg of NPK during irrigated condition and 150 and 25 kg of NPK during rain-fed condition is recommended. However, due to large spatial variability and temporal variability limits the efficient nitrogen use efficiency. Hence, in order to synchronize the crop needs with the nitrogen application, we have used two optical proximal sensors, that is green seeker and splat chlorophyll meter, to for efficient management of nitrogen in maize. With the above mentioned objective, the experiment was conducted during 2020 and 2021 in strip plot design by having two vertical strips, that is irrigated and rain-fed conditions, and by having six precision nitrogen management practices along with RDF as well as absolute control. Let me explain about the precision nitrogen management treatments. We have taken two sensors, that is green seeker as well as pad chlorophyll meter. Based on these two sensors, we have established two indices, that is sufficiency index and as well as response index. Sufficiency index from the using the SPAD values. In order to establish this sufficiency index, we have established two enriched treatments, that is by applying 200% of nitrogen, recommended amount of nitrogen. The sufficiency index is calculated as the SPAD value of test plot to the SPAD value of enriched plot, which is expressed in percentage, and the treatment goes like this: nitrogen management through SPAD sufficiency index of 86 to 90, and treatment 2 indicates 91 to 95, and treatment 3 indicates 96 to 100%. Whenever the set values SPAD in sufficiency index values of the test plot, that is the treatment plot, falls in the set range, that is 86 to 90, 91 to 95, and 96 to 100, the 25% of the recommended amount of nitrogen is applied to the plots. Similar to the SPAD sufficiency index, response index was calculated by using the NDVI values obtained from green seeker. That is NDVI values, response index is calculated as NDVI values taken from the enriched plot to the NDVI values taken from the test plot, which values ranges from 1 to 1.41. That is, whenever the values response index values falls in the range of 1.11 to 1.25 or 1.26 to 1.40 or more than 1.41, the recommended amount of 25% of the recommended amount of nitrogen is applied to the plot. These are the aerial drone based aerial images which are taken during the crop growing season. Here we can clearly visualize the effect of varied levels of nitrogen application on the growth of maize and leaf color. And coming to the results, grain yield was significantly higher under irrigated condition as compared to the rain-fed condition. And among the precision nitrogen management practices, that is T3, that is application of nitrogen at sufficiency index of 96 to 100% recorded significantly higher grain yield and total nitrogen uptake, total phosphorus uptake, and total potassium uptake as compared to the other precision nitrogen management treatments. However, that is nitrogen application at sufficiency index of 96 to 100% and response index of 1.11 to 1.25 has recorded on par grain yield, total nitrogen uptake, total N, P, and K uptake as compared to the rest of the treatments. Coming to the interactions, significantly higher grain yield and total nitrogen, phosphorus, and potassium uptake was recorded under the application of nitrogen at SPAD sufficiency index of 96 to 100% under irrigated conditions, which was mainly on par with the application of nitrogen at SPAD sufficiency index of 91 to 95% and response index of 1.11 to 1.25. And these are the images of the crops which are obtained during the research period. And coming to the nitrogen use efficiency, whereas significantly higher nitrogen use efficiency was obtained under T4 treatment, that is application of nitrogen at sufficiency response index of 1.11 to 1.25, that is by using green seeker, which was significantly higher, as well as among the SPAD based treatments, sufficiency index of 86 to 90% recorded higher nitrogen use efficiency as compared to the rest of the treatments. Coming to the all the growth parameters and yield parameters were significantly and positively correlated with the SPAD values as well as NDVI values taken out during the growth period. And coming to the conclusion, grain yield was significantly higher under irrigated conditions, as well as among the precision nitrogen management practices. Sufficiency index of 96 to 100, 91 to 95, and response index of 1.11 to 1.25 were the main treatments which helped us to get the higher and significantly higher yield as compared to the RDF treatment under irrigated conditions, whereas the nitrogen use efficiency was also superior superior under sufficiency index of 86 to 90% and response index of 1.11 to 1.25 as compared to the RDF treatments. Thank you. Hello.
Nice presentation, Shiv Shankar. You can which hybrid is used in hybrid in maize?
Yes, sir. We have used NK6240 hybrid, sir, which is a national.
What is yield potential of
for
that hybrid?
Comparing both irrigated and rain-fed.
Rain-fed.
Yes, sir. 50
okay,
to
okay.
60. Yes.
Hello, your voice is not audible.
Yes, sir. Is it audible now, sir?
Okay. Yeah.
Yes, sir. 50 to 60 quintal per hectare, sir. It may go high up to 80 quintal, sir. But under optimal condition, it may yield 50 to 60 quintal under irrigated condition, and for rain-fed condition, 40 to 50 quintals per hectare.
Okay. Madam, please.
Yeah, I think it was a good study, especially with maize, which requires exhaustive nitrogen. So there could be definitely a saving over a large area, I believe, sir.
Yes, madam. Whenever it has taken for a large area, we can save either nutrient, or we can increase the efficiency of the nutrient so that we can get higher yield per amount of nutrient applied.
Definitely, because it should reach the farmers. Otherwise, the essence of the study which we have done will not be reached. What I believe is a good study and good.
Yes, madam. Unless we get the technologies into the farmer's hand, it is very difficult to get into the farm.
Because otherwise, it will be only in the knowledge purpose. That's all.
Yes, madam. But it can be used for algorithm making, madam, for future purpose.
Yeah. But that level of what you say ease should be there, and it should reach the farmer through the technical person, I believe.
Yes, madam.
The extension linkage. Definitely.
Yes, madam.
Okay, good presentation.
Okay, thank you.
So, Kareen Sai, are you there?
Yes, sir.
We can continue with you. You can share your screen.
Is my screen visible, sir?
Yes. Please continue.
Good morning, everyone. Myself, Sai Kitna. I'm going to present on title Azolla, a sustainable source for animal feed on the food. Introduction. The Azolla plant, also called the Wonder Friend, has several species indigenous to different areas globally. Azolla is highly productive plant. It doubles its biomass in 3 to 10 days. Depend upon the condition, and yield can be reached to 8 to 10 tons fresh matter hectare in rice fields. They form a symbiotic relationship between the cyanobacterium anabia, which fixes atmospheric nitrogen, giving the plant access to the essential nutrients. The typical limiting factor for its growth is phosphorus and abundance of phosphorus, for example, due to eutrophication or chemical runoff, often leads to Azolla blooms. Azolla reproduces sexually and asexually by splitting. Uses of Azolla as a livestock. It is used high content in proteins, essentially amino acids, vitamins. In vitamins, they are
vitamin A, vitamin B12 and beta carotene, growth promoter, and minerals. It ability to proliferate without inorganic nitrogen fertilization, and it is used in the poultry feeding. Birds with 75% of the regular field and 12.5% in the form of azolla and an almost equal weight to birds with 100% regular food. The number of eggs laid per bird and the quality of the eggs, the yellow yolk protein of egg being more predominant and yellowish, was better than in birds not fed on azolla. Live weight production number and protein efficiency were significantly improved. Feed conservation ratio and energy efficiency were significantly improved. The total boiler was cost significantly lower with the azolla meal. As a feed for mallards, fresh azolla can partially replace whole soybeans up to level of about 20% of the total curd protein in diets of lactating ducks based on sugarcane juice without any problem or no adverse effect to growth rate or health. As a biofertilizer, it is used. Anaerobic fermentation of azolla or mixture of azolla and rice straws produces methane gas which can be utilized as a fuel. The remaining efficient can be used as a fertilizer and it contains all of the nutrients originally incorporated in the plant tissues, and it is used as a weed control. In paddy form, azolla forms a thick layer and cover all farm areas and work as an organic mulching which does not allow to produce weed. Also, its slow water evaporation rate and maintains soil moisture for long time. And it will be used as a mosquito control. Azolla restricts mosquito breeding process, and thus azolla also called as mosquito fern. Azolla cultivation techniques. Artificial, can be cultivated in the artificial pond, and for creating azolla cultivation pond, partially shaded area is selected. Dig out the soil from the pond and level the soil after the spread and plastic sheet around the ground to prevent water loss. Make sure the pond is at least 20 centimeters deep. Add some soil uniformly on the plastic sheet in the pond for 2 meters into 2 meters size pond. Add 10 to 15 kgs of the soil next. Azolla needs phosphorus to grow well. You can use super phosphate along with the cow dung slurry. Cow dung increases the available nutrients. Use cow dung 4 to 5 days old. Next, fill the pond with the water to level of about 10 centimeters. This will allow the short root of the azolla plant to float freely. Then leaves the pond for 2 to 3 days so ingredients can settle. After 2 to 3 days,
Please don't read us in cultivation technique. Please can conclude. Confirm, please.
Yeah, just show the pics, how it is there day 1, day 5, day 10.
This is.
And future prospects you can just highlight. Okay?
Okay, ma'am. This is the picture representation of azolla cultivation. Day 1, how it is there, and day 5 and day 10. And future prospects of azolla in the agriculture. The World Bank's development marketplace funded converting rice fields into a green fertilizer factories. More or less exposed uses for azolla are wastewater treatments, control of weeds, algae and mosquitoes, medicine and production of biofuels such as biogas, biomethanol and hydrogen. The integrated use of azolla with rice and fish farming has been developed, which can enhance the farmer's income while reduce the use of pesticides and fertilizers and continuously environmental pollution.
Okay, you just show the pictorial representation of. You are a UG undergraduate student?
Ma'am.
What are you pursuing now, study?
Madam?
You are in which year now?
Madam, 4th.
4th year, okay. So it is a review article, no?
Yes, madam. Yes.
Oh. Okay, you told direct sunlight will damage azolla. So what happens? How does it become if there is a direct sunlight?
Madam, azolla required only shaded because to increase the biomass, it should be required in the shaded place only, ma'am, not in the hot climate.
Generally, it gets charred and it dies. So partial sunlight is only required. So when you apply in the rice fields, what
Yes, ma'am.
happens? It has got a partial shading because of the rice crop, isn't it?
Yes, ma'am.
Okay, sir. If any queries are there, otherwise we can go to the next presentation, please. Yes, Sai Kirtana. Okay. All the best for your near future endeavors.
Okay, ma'am.
Ayushi Chauhan, are you here?
Hello, am I audible, sir?
Yes, yes.
Okay, sir. A very good afternoon to you all. Myself, Ayushi Chauhan. I'm from Amity University, Noida. I'm going to present my work on synergistic association of nanoparticles with Serendipita indica and its effect on rice. Nanotechnology is a branch of science that deals with material ranging from 1 nanometer to 100 nanometer. I have employed this nanotechnology in my research work. I have biosynthesized silver nanoparticles from aloe vera extract, and their effect has been examined on the growth of antibiotic fungus Serendipita indica. Growth was measured in terms of trisalvate and spore count. Further, the effect of this nano-embedded fungus has been examined on the growth of rice plant. Now, coming to the methodology, I have initially, I have biosynthesized silver nanoparticles from aloe vera extract, and silver nitrate has been utilized as a precursor. Silver nitrate solution was prepared by mixing aloe vera extract in a ratio of 1:9 and incubated at a room temperature for 24 hours. After incubation, a change in color was observed. The color changes from white to grayish, which is actually a primary indication of silver nanoparticle solution. To analyze the size of nanoparticles, dynamic light scattering technique has been employed, where size was measured up to 173 nanometer. For more morphological details, scanning electron microscopy analysis has been performed, where the average size observed was 70 nanometer. After characterization, these nanoparticles were co-cultured with the fungus at 100 ppm and incubated at 28 degrees Celsius for 10 days. After which, the increase in growth of fungus was measured, with an increase of 12.4% in dry cell weight and 20.47% in spore count. Now, we have analyzed the effect of this nano-embedded fungus, or we can say nanobioformulation on the growth of rice. This nano-embedded fungus was introduced to rice in the form of rutonic. Rutonic is prepared by mixing 2% of fungal biomass with 100 grams of magnesium sulfide. Seed treatment of this rutonic was given to the desired seed, and they were allowed to incubate in seed overnight and sown in soil by the regular method. Plants were sown in pots and triplicates and grown at a temperature ranging from 28 degrees Celsius to 36 degrees Celsius, and they were allowed to grow for 45 days in pots. After 45 days, growth of plant with different treatments were observed. An increase in root and shoot length was observed. Root length and shoot length were almost doubled. The number of roots were also increased. That is, the number of roots in untreated plant was 2, whereas it increases to 3 in the nano formulation treated plant. Similarly, number of leaves also increases from number of leaves also increases from 2 to 9 in nano bioformulation treated plant. Now, talking about the conclusion, in this study, we have created a biofertilizer, this nano formulation, nano embedded fungus. It's a biofertilizer which is proved to enhance the growth of a plant. It has enhanced the seed germination, promote early blooming plants, and enhance the yield of various plant. In our research, we are about to conduct field trials. Till the date, the data we have obtained is it has enhanced the root shoot length, number of root, number of leaves of our plants. Thank you, sir and ma'am.
Ayushi, nanoparticle, suppose if you say that it is a nanoparticle, so how do you conclude that it is a nanoparticle by characterizing its size? Do we have
Excuse me, how do we say nanoparticle? It's a nanoparticle.
Yeah.
मैम मैम हमने इसका SAM analysis कराया था. We analyzed its morphological details, and after that we also went for XRD.
Have that facility at you, or you have given it somewhere after I mean synthesizing the nanoparticles?
Please ma'am, please repeat.
आपके पास वो facility है क्या, X-ray diffraction and other size characterization का lab है?
Yes ma'am, yes ma'am, yes ma'am, yes ma'am, we have that in MET.
So just you have done on pot culture, I think still it needs further research, isn't it?
Yes ma'am, these are the physical parameters only. We'll go for the these chlorophyll content and photosynthetic pigmentation, and also we'll go for field trials in MENA.
Okay, sir. If any more queries are there, they can be cleared, please.
Okay, nice. Can you have conducted pot studies, Aisha? Is it in
Thank you
easily
so much,
available?
sir.
Which nanoparticles you used?
So which kind of nanoparticle I have used? So I
But is
have
it
used silver nanoparticle in the current study.
yes.
I have already worked on zinc oxide nanoparticles, and they have shown amazing results. So currently I'm working on silver nanoparticles. Silver nanoparticles are known for seed germination. They enhance seed germination in plants. There's study in which they have proved that silver nanoparticles have enhance the seed germination rate and early blooming in plants. So right now I'm conducting this effect of this nanoparticle, nano-embedded fungus on rice. I'm trying to examine its effect on a rice plant.
Definitely is a very nice studies because of this advanced research technology. And is it in
Thank you so much.
nanoparticle is available in market in?
Nanoparticle अगर हम market से purchase करें, it's actually very expensive. I have biosynthesized it from aloe vera extract. Although I have used that silver nitrate in it, but for reducing and capping agent, I have used aloe vera extract. You know, we can't cut off the complete cost, but थोड़ा सा तो हम लोग उसके cost को reduce कर सकते हैं. So that's why as a capping and reducing agent, I have used aloe vera extract.
Definitely, we are in the root length, shoot length, and number of roots. Because of it all, we can also significantly is also a very good response in nanoparticles. Kaira.
Yes, sir. Yes, sir.
Review articles. Yes, yes.
Yes, sir.
Okay, nice presentation.
Thank you so much, sir.
Okay. Please.
So next person, please. Be ready for presentation.
Arushika, are you there?
Yes, sir.
So we can continue. I make you co-host, you can share your screen.
Yes, sir. Is my screen visible, sir?
Yes.
Please visible. You can go for presentation mode.
Yes, sir. Good morning, one and all. I am Arushika Swai, PhD Research Scholar from the Department of Vegetable Science, OUAT Bhubaneswar. Today I am going to present post-presentation on studies on correlation and path coefficient analysis in summer squash. Summer squash, scientifically known as Cucurbita pepo, belongs to family Cucurbitaceae, having the chromosome number 2n equal to 40, having the wide variability. It is also called as the vegetable marrow, zucchini, and or the chappan kadu. It has high nutritive and medicinal value as compared to other vegetable crops like vitamin A, vitamin C, niacin, and the fibers. It also prevents cancer, heart diseases, and inflammation problems such as the asthma and arthritis. And comes to the methodology, the experiment was conducted in Rabi season 2021 at Horticulture Research Farm Rana Devi MS Swaminatham School of Agriculture at Paralakhemandi, Odisha. In this, we have taken 16 genotypes having 3 replication and 16 treatments, and the table represents the correlation and path coefficient analysis of different characters of summer squash with respect to yield per plant. And these are the 13 characters we have taken. And from the correlation study, we get the result that in genotypic level, number of fruit per plant, number of female flower, number of male flower, number of harvest, fruit yield per plot have the significant positively significant correlation with respect to fruit yield per plant. And in case of phenotypic level, we found that average fruit weight, number of fruit per plant, number of female flower, number of male flower, and number of harvest fruit yield plot has the highest positive significance with respect to fruit yield per plant. And in case of path coefficient analysis, we found that the fruit girth shows the maximum positive and direct effect, followed by the number of male flowers, number of harvest, fruit yield per plot, node at which first female flower appear, and the number of fruit per plant at the phenotypic level. At the end, we conclude that in that 16 cultivar we have taken, in that is that in these are the 3 cultivars, Green Star, Bipin, and Pusa Alankar, having the positive effect and highest yield and number superior variety as compared to high yield and number of fruit per plants, and wide variability has been found in the different horticultural states in summer squash. Thank you.
So, I have a doubt because when you have taken different genotypes,
Yes, sir.
would we conclude that you have given across the genotypes, but could you give 1 or 2 genotypes which could be more reliable or correlated with the yield and yield parameters?
Ma'am, that Pusa Alankar, which we have collected from IRI New Delhi, and Green Star and Bipin has the good yield and in number of fruit and plant, fruit per plants also it is good. This variety we can recommend for farmers in South Odisha condition.
That's what. That should be the final point, isn't it?
Yes, ma'am.
Otherwise, just correlation and saying that it is positive or negative correlation will not
Yes.
give a correct inference of the study which you have done. Okay.
Yes, sir.
Sir, from any other queries from the other end? If there are any queries or clarifications, otherwise we'll invite upon the next speaker, sir.
Shivangi, are you here?
क्या हुआ रोहित जी?
Yes, sir.
Okay, we can continue with you. Shivangi.
मैडम थोड़ा तेज बोलिए आप.
Okay, sir.
And we can
I'm just sharing my screen, yes, sir. So is my screen visible?
Yes,
Yeah,
ma'am.
please.
Just go for PPT mode.
Presentation mode पे कर दीजिए.
Please go presentation mode.
Okay. Okay, sir.
Okay, go ahead, please.
So should I start?
Please.
Good afternoon, respected all. My name is Shivangi Verma. I am a student pursuing PhD from Padnagar University, Department of Genetics and Plant Breeding. So topic of my today's poster presentation is morphological and molecular characterization of soybean, genotypes for improved yield and resistance to yellow mosaic disease. As we all know that soybean is known as a miracle crop, and it is widely grown throughout the world.
as we all know that it is widely grown throughout the world, and India ranks 5th in its production and area-wise 4th. And soybean is rich in its linoleic acid. It is rich in linoleic acid and oleic acid content, and it is highly rich in its protein content as well as oil content. Protein it is 40% and oil it is 20%. But since we know that it is a very rich leguminous crop and it has high potential among all other crop and high the potential of this particular crop is high because it is very good leguminous crop, and but it faces many it restricts the growth because of its biotic and abiotic factors, and out of which the most important factor which restricts its productivity is yellow mosaic disease. So yellow mosaic disease, it is caused by mung bean yellow mosaic virus. And so as to control this disease and to manage it, we have to work on the field level as well as in the lab. So when we say in the field level, so it is very important as a breeder to select and do very fine screening. So here the plants, they are phenotypically, they are selected and screened out. And when we go for in the lab, we go for DNA extraction, where at the seedling stage also we can do, as well as in the later stages also we can go for it. So when we run the molecular markers, it targets the gene responsible for providing resistance to particular to YMB disease. And when we talk at field level, so there are nodes per unit land area, there are pods per node, there are pods per unit land area, there are seeds per pod, there are seeds per unit land area, weight per seed. They are all factors that are responsible for increasing the yield of soybean plant. Then secondly, when I talk about the land level, lab work, so there are many markers that are being used for extracting the gene that will be responsible for providing resistance towards the YMB disease. So that are SCAR YMB, STAT 479, STAT 564, STAT 543, STAT 553, STAT 312, and STAT 297 respectively. There are many varieties that are being released in Pannagar. One of the variety that is very important is NRCSL, one that has been released by Soyabean Research Institute. And there is many other works that is being done on the yield for improving the yield in Pannagar, and there are many other varieties that are released by Pantnagar. So further, I would like to say that in conclusion, that if there is a work that is done at the field level as well as in the lab level, so we can reduce our time for extraction of the particular germplasm which will provide resistance to YMB disease, and that will save our time also and will do precision breeding. Thank you.
Nice presentation. In
Thank you.
regarding, are you
Yes.
hearing?
Yes, sir.
In regarding yellow mosaic disease is severe disease can go for late sowing. Almost
Yes.
also in the month of June second week, in especially Karnataka, Maharashtra, Madhya Pradesh is commonly growing in the month. But you can what is the extent of somehow you can go for your whatever developed in the genotypes. Is it any what is the extent of the reduce the yield mosaic disease incidence in the soybean crop?
Sir, can you just pardon once more, please? I couldn't.
That is, you can go for delay sowing of soybean crop is a severe disease in yellow mosaic disease.
Yes, sir. In the central part, sir.
Yes.
Yes, sir.
Central part and even southern parts also.
Yes, sir.
But
In the
what is
southern.
what you developed many resistant tried in many genotypes. What is the yield of extent in reduce the yellow mosaic diseases?
Sir, in the case of yellow mosaic, then it decreases the yield up to 80%, sir. There is loss up to 80%, sir. So yellow mosaic causes losses up to 80%, sir.
Okay.
So what are the common practices that farmers generally do? Are they aware of any practices or just only sowing the tolerant varieties?
No, sir. No, ma'am. We are aware about the latest varieties that are being grown, especially the NRC 130, NRC 138, NRC 142, sir.
Okay. Okay. Good presentation.
Okay, thank you, sir. Thank you, ma'am.
I think we can call upon the next presenter, please.
Pavitra, are you there? Pavitra B.
Sir.
Still, how many presenters are there, Ankuji?
I think, sir.
With this, we are going for the 14th presentation. I think we have 30 plus now, sir.
I think 9 are there. 9 or 10 are
32 or something are there.
Yes,
I think there is a.
Yes, sir.
Okay, go ahead. Go ahead. Next presenter, please.
Pavitra.
Good afternoon, everyone. Myself, Pavitra. I'm a PhD scholar in Department of Agriculture Statistics, UBKV, West Bengal. My topic is weather-based regression models for predicting sorghum rust. Sorghum is the fifth leading cereal grain worldwide after wheat, rice, maize, and barley in terms of area and production. One of the limiting factors for the production of sorghum is disease incidence. Rust of sorghum is caused by Coccinia purpurea, and damage caused by the rust depends on the time of infection and type of varieties we have grown. If the infection occurs in early stages of growth and premature drying of leaves results in reduction of yield, weather plays a major role in crop growth as well as development, pest and disease. The relationship between disease development and environmental factors is a key component of the disease forecasting system, as said by Van and Zhu in 2003. The models based on the weather parameters can provide accurate forewarning for disease so that effective plant protection measures can be taken in good time to protect the crop. Our objective is to develop weather-based prediction model for sorghum rust. And our study is based on the available secondary data for 15 years from 2006 to 2022. The experimental data was collected from AICRP sorghum, and weather data was collected from Department of Agrometeorology, CMIT, UAS Harvard. Weather-based disease prediction model was developed by using multiple linear regression, and stepwise regression was used to select independent variables that are to be used in the final model. It involves adding or removing the potential explanatory variables in succession and testing the statistical significance of each iteration. Our research reveals that temperature and precipitation had positive correlation with rust incidence, whereas parameters like relative humidity, wind speed, radiation, and heat flux had negative correlation. And multiple linear regression model explains 65.45% of variation that occurs in rust incident through all the 6 weather parameters which we have considered. And the model is given in table 1. Stepwise regression gives a model that explains 65.09% of variation in occurrence of sorghum rust with only 4 weather parameters like relative humidity, wind speed, radiation, and heat flux. And all the VIF values, that variance inflation factor values for stepwise regression model is less than 10. So we can use stepwise regression model for predicting the sorghum rust in Harvard region. Thank you.
So what is the step-down regression, Pavitra?
Ma'am, in multiple linear regression, ma'am, we have considered so many multiple variables. Some variables which may be non-significant also, and so many variables are there, no, ma'am. So we need to reduce the number of variables, we need to consider only significant variables, ma'am, which is significantly contributing to the disease incidence. So we use stepwise regression, ma'am. Like first we consider variables.
I have an idea. I think this is a very simple model, isn't it?
Yes, ma'am. Actually, ma'am, for other statistical model, more than 30 data points we need, ma'am. Here we are having only 60. So I'm using only multiple linear and stepwise regression model.
Yeah, out of all these things, in one conclusion, one point, what would you say that which is the major contributing factor with much correlation with respect to sorghum rust?
Ma'am, according to The parameters which I have considered, heat flux and radiation, they are contributing more, ma'am.
What do you mean by heat flux? What is heat flux? Because temperature and all, we have a direct idea. So could you throw some light on heat flux? Are you there, Pavitra?
Hello. Ma'am, am I audible?
Yeah, what is heat flux actually?
Ma'am, heat flow rate, it is also called heat flux, ma'am. Amount of heat flowing.
How do you account for it? Because the remaining things we get from the hygromet observatory. Yes or no? When we have a hygromet observatory, we can record it. How can we take this heat flux?
Ma'am, by using surface temperature, I don't know exactly, ma'am, but by using surface temperature, they have measured like that.
Surface temperature of what? Whether it is soil or the foliage.
The correct
Foliage.
foliage.
Foliage, ma'am.
Yes, foliage. As an automatic weather station based on the information they collected, madam, weather based.
Yeah, I just wanted to know, sir, whether she has an idea over that.
No. Yes, okay, madam. This is collected. She's collected with SRP and Sorghum Center. Is it Pavitra? Is it right, Pavitra?
Yes, sir. Sorghum, ASAP Sorghum Harvard Center, sir.
Okay. In which season you collected? Kharif or Rabi?
Sir, both season I have collected, sir, but rust is more in Rabi season.
Oh, it is
sir,
compiled
so
to both seasons because of rust. Okay. Nice presentation. Nice presentation. Next presenters, please.
All the best, Pavitra.
Thank you, ma'am.
Next presenter, please.
Anusha, are you there? Yeah. Anusha, you can unmute yourself. Already sharing the screen. It's your browser, Chrome browser. It's not allowing you to, Yeah, sure. Our next presenter will be Aarti. So, Aarti ma'am, are you there?
Yes, sir.
Okay, we can continue with you, ma'am.
Arati, please share your presentation.
Hello, sir. Is it visible, sir?
Yes, visible. Please go ahead. You can go for presentation mode.
Oh, it is a oral presentation then, not poster, isn't it?
Yes, oral presentation. Yes, madam.
Oh,
Yes, ma'am.
go ahead, Aarti.
Good afternoon, everyone. My name is Aarti, and I'm pursuing my PhD from CCS HU Hisar. And my topic is impact of VAM inoculation and phosphorus level on NPK uptake in wheat, grain, and straw in aridisol and septisol soils of Haryana. So the flow of the presentation will be first introduction, then objective, then the experimental details, initial soil status, the results, and the conclusion. First, let's talk about the introduction. As we are all aware that the wheat is the dominant staple crop of the world, and when talking about India, it is grown on the country's north and the northwest region. It is dominant Rabi cereal crop with average productivity of 3,424 kg per hectare. And in India, the largest area of wheat is present. But when we talk about the production, it comes after China. And when we talk about the phosphorus, it is very essential in making the nutrient It's very essential macronutrient and which directly affect the yield of the wheat in many aspects.
Arti, please go to methods of material and results, please.
Okay, sir.
You need to finish in 5 minutes, please. 5 to 6 minutes.
Yes, ma'am. And when we all know that the phosphorus efficiency is very limited, and to increase the phosphorus efficiency, VAM is very efficient phosphorus mobilizer. And
As Ashoka sir told, you can just focus on your results. That will give you more time and efficiently you can present.
Okay, ma'am. The experimental details were the crop used were wheat. The variety was WH1105 in two different soil, that is light and heavy textured soil. There were 4 different rate of phosphorus, that is 0, 30, 45 and 60 kg per hectare, and each with VAM and without VAM. The experiment was conducted in the Greenhouse Department of Soil Science, CCSHI Hisar, and the experimental design used was the 3 factorial design, in which 3 applications used, and there were 16 treatments. 8 were of heavy soils and 8 were of light soils. In heavy soils with the different rate, with 0 rate, the different VAM application with 0 VAM and no VAM, like these the treatment combinations were made. And this is the initial soil status. The pH of the heavy soils was 8.12 and the light soil was 7.81. The EC was 0.36 decimon per meter and the light soil was 0.44. The organic carbon status of heavy soil was found to be 0.61%, while of the light soil it was found 0.46%. The available N content in kg per hectare of soil was 163.52 and of light soil it was 119.40, while the available phosphorus was 67.30 and 23.6, and the available potassium was 380.8 and 240.6 kg per hectare respectively. The soil texture of heavy soil was clay loam, while the light soil was sandy loam soil. And this is the result, like the effect of VAM inoculation phosphorus level on nitrogen uptake in different soils. The 1 to 8 treatment shows the treatments of heavy soil, and the 9 to 16 treatments they shows the light soil treatments. And in both we can observe that in both soils, light and heavy soils, with increase in the phosphorus level, that is from 0 to 30, 45 and 60, there is increase in the nitrogen uptake in both grain and straw, and higher values of nitrogen uptake were observed in heavy soils as compared to the light soils. This may be due to the reason that the higher clay content present in the heavy soils and higher initial nutrient status present in heavy soils. And with increase in the phosphorus level and with application of VAM also, the nitrogen uptake increases in both grain and straw. While the conjugate effect there were more prominent, while the conjugation effect of both is more prominent compared to the single or individual effect. And talking about the phosphorus uptake with the VAM and phosphorus level, increasing the phosphorus level, the same trend is observed that when we increase the level of phosphorus in application from 0 to 60, the phosphorus uptake in both grain and straw increase in both heavy and light soil. The phosphorus uptake increase may be due to the increase in the concentration in soil, roots, or in the grain, which ultimately increases the phosphorus uptake in plant. And within VAM also, the uptake of phosphorus increases as VAM increases the root surface area through its hyphal network, and through producing the organic acids, it increases the availability of nutrients to soil. And the talking about the potassium status also, it increases, the potassium status also increases with increase in the phosphorus level. But the grain, we can observe from the graph that the potassium in the straw was found comparatively higher than in the grain. From this, we can conclude that the combined application of phosphorus and VAM had more beneficial effect over the single application. And in both light and heavy soils, the 60 kg phosphorus application recorded the higher value, but the 45 kg phosphorus with VAM also found to be at par with that. And VAM inoculation also increases the nitrogen uptake in grain and straw to 12.2% and 15.8%, and phosphorus uptake from 14.9% in grain and 19.00% in straw. And higher values of nutrient uptake was observed in heavy soils than in light soils. Thank you.
Aarti, VAM actually, what is the main role of VAM?
Ma'am, VAM is a vesicular or vascular mycorrhiza which increases the nutrients mobility through its hyphal network और मैम रूट्स के लिए सरफेस एरिया इंक्रीज कर देता है मैम वो.
But why it is not going ahead into the stream of the farmers, because they are continuously going for the complex fertilizers, but still VAM is only pertinent to the labs or to the technical studies or presentations.
Ma'am, the field studies of VAM are very limited, and in some studies also, field studies, ma'am, their negative effect also seen. It is showing the positive effect also, matlab only in the pot culture, ma'am. There is need to do some research on field also, ma'am. तो पता चलेगा that it is actively.
All these microbes and all, they have wonderful and what to say, wonders they do. But at field level, because of the like abiotic factors, especially temperature, moisture availability and all, have a greater role to play.
Yes, ma'am.
The effectiveness of this PGPRs, isn't it?
Yes, ma'am. Effectiveness decreases on field level.
Yes, sir. I have done with still any queries?
Anusha, are you there?
Yes, sir.
We can continue.
Yes. Good morning, everyone. I'm Anusha from Punjab Agriculture University, and I'm here to present my poster on the review Harnessing Molecular Techniques to Enhance Heat Stress Resilience in Vegetables. So, what is heat stress? Heat stress occurs in crop plants when the temperature exceeds the optimal levels for growth and development, thereby negatively impacting the various physiological processes of the plants, ultimately decreasing the plant yield. And we know that climate change is becoming a serious threat to crop production. Due to the abnormal occurrence of weather patterns like heat waves, there is an urgent need to develop resilient varieties which are capable of withstanding these extreme temperatures. So, in aid to this, molecular techniques stand as a powerful tool to identify the key genes and the pathways which are involved in the imparting the heat tolerance. So, where does the need arise? Because of the impact of heat stress on vegetables, we can see some of the examples here. There is abscission of flowers and flower buds in bell pepper, tip burn, head discoloration, and buttoning in cole crops. There is significant reduction of female flowers in the cucurbits. There is also ovule abortion, poor fruit set, flower and fruit drop in hot pepper. There is decrease in germination and pod quality in okra. There is reduction of bulb size and also bulb quality parameters in onion. And there is poor fruit set, fruit and flower drop, along with some of the physiological disorders such as blossom and drought and fruit cracking in tomato. So now that we have seen the detrimental effects of heat stress on the vegetables, let us understand the plant response that determines its ability to increase the tolerance for its high temperature. Some of them include morpho-anatomical alterations, physiological and biochemical alterations. These are: the plant may reduce its cell size, it regulates the opening and closing of stomata, and it increases the number of trichomes. And when it comes to the physiological alterations, we can see the accumulation of compatible osmolytes such as proline, glycine, betaine, sucrose, etc. There is increased retention of water in plants. There is better stomatal regulations. And when we come to the biochemical alterations, there is increase in antioxidants such as enzymes such as sulfur oxide dismutase, peroxidase, etc., which help in scavenging the free radicals and thereby decrease in the ROS generation. And there is also less photooxidative damage. These are the physiological and other responses. When we come to the molecular responses, there is heat shock proteins. Heat shock proteins are the molecular chaperones which are involved in the protein folding and stabilization under heat stress. Now, let us see what are the modern approaches we can use to develop varieties which impart tolerance. Some of them are QTL mapping, genome-wide association studies, transcriptome analysis, marker-assisted selection, transgenics, and also genome editing. So now let us see one by one. The QTL map, with the help of QTL mapping, we can identify the major and minor QTLs which is responsible for imparting heat stress tolerance. And if you want to go for fine mapping, the next step is GWAS, that is genome-wide association studies. Once the candidate gene or the QTL is identified, we can introgress that into different genetic backgrounds to finally develop a heat stress tolerant cultivar. Next, when we see the cutting edge technologies like genome editing, here it gives us a precise manipulation for a manipulation of candidate genes by either knockout or knock-in approaches. And now presently another cutting edge technology is the omics, that is genomics, transcriptomics, proteomics, and metabolomics. With the help of these, we can go for gene profiling, expression studies, and identification of proteins responsible for heat stress tolerance, and post-transcriptional modification studies, and regulation of metabolic pathways such as jasmonic acid pathway or salicylic acid pathway, which is actively known to impart tolerance, that is heat stress tolerance, in the varieties. So we can tell that with all these approaches together, we can use these tools to empower the breeders to use it for the development of heat stress tolerant varieties to ensure the food security. So to conclude, I can say that by deciphering these molecular pathways which are associated with the heat stress response and employing precision breeding approaches, one can create vegetable varieties which are resilient to high temperatures. Thank you.
This is based on a review, isn't it?
Yes, ma'am. Yes, ma'am.
What are you doing now? Undergrad?
Currently, I'm pursuing PhD. I'm in my second year PhD.
And you could have focused something from your MSc, no? PG?
Ma'am, I've already presented my MSc research, so I thought I would give a review.
Opportunity for the undergrads, actually. I had a doubt because it is a review one.
Okay, ma'am. Ma'am, I've already presented it and my research work is currently going on. So I thought I would give a review poster.
Okay. Okay. If there are any no queries, next candidate can please share.
Mr. Vinay, are you there?
Oh, yes, sir.
Yes, sir. We can continue with you.
Sir, is it visible?
Yes. Please continue.
Good afternoon, organizers and my dear friends. Myself, Vinay. My topic was forecasting forecasting tomato price in Karnataka Kolar market, a comparative analysis in time series models. Introduction. Tomato is one of the most important cash crops in the state of Karnataka.
Please don't focus much on the introduction. You can just go ahead directly to that so that you will have more time.
Yes, ma'am.
Okay.
The objective of the study was to forecast the monthly tomato price for the year 2020-24 by using time series models. The materials I collected from ATMANIRBHAR, that is time series data on monthly tomato price in Kolar market of Karnataka from January 2010 to December 2020-2023. The whole data was split into two sets, that is 80% as a training set and 20% as a testing set. And I used 7 time series models in order to forecasting the tomato price of Kolar market Karnataka. And the 7 models are as follows: the simple exponential smoothing, double exponential smoothing, triple exponential smoothing, auto regressive integrated moving average, that is ARIMA, and seasonal ARIMA, BATS and T-BATS, whereas B represents Buck-Cox transformation, A represents ARIMA, T represents trend, and S represents seasonality, whereas T-BAT represents trigonometric seasonality. And I find out the accuracy of both training set and testing set by using RMSE, that is root mean square error. After fitting all these 7 models, I found out one best models based on RMSE. That best models will be using for forecasting the monthly tomato price for the year 2020-24. The parameters of all the 7 models was calculated based on grid search by using R software. In order to fit any time series model, we should know whether the time series model is follows a stationarity or not. I used ADF test in order to check the stationarity of the time series model. And I took first differentiation in order to transfer the non-stationarity data into stationarity model. And I used auto ARIMA in order to know the particular parameters of ARIMA and particular parameters of ARIMA based on grid search. I found out these are the BATS parameters and this is the T-BATS parameters. And accuracy of the models was calculated by using RMSE criteria based on both training set and testing set. The RMSE is telling that whichever is the less RMSE as compared to all other models, that one is the best model. But we can see from here that the T-BATS model is showing less RMSE as compared to all other models, as well as in training set also, as well as in testing set also. And this is the plot of observed and fitted values from the T-BATS model. Also, we can see here that observed and fitted values from the T-BATS model are all closely related. By using this one, we can tell that the T-BATS model was performing well as compared to all other 6 models, and therefore we forecasted the monthly wholesale price of tomato by using T-BATS model. And from the results, we can see that in the July month, we can see there is a more price as compared to all other months, followed by June. From this result, we can tell that we can suggest to farmers that they can go for planting of tomato crop accordingly the season, so that this study this study will help the farmers in order to make their profit in tomato farming. Thank you.
So I hope as a statistician you have just given to plant in that particular during that particular time. But I hope even if the study has focused on the varieties, because you cannot sow all the varieties at the time which you have given, isn't it?
Yes,
so something focused on the varieties versus dates in association with the horticulture would give a definite conclusion or the recommendation. Yes.
Yes, ma'am.
You have just seen on the dates and the produce and the price.
Yes, ma'am.
The real thing which is missing is the apt variety. So kindly, if you could do along with the interdisciplinary work, it would be better, I think.
Yes, ma'am.
Yeah.
I will check.
Yeah, because it is only one way from your side, market
yes,
price and all. Yes, I hope you
yes.
have understood it.
Yes, ma'am.
There are other parameters like weather parameters, varieties which need to be taken into account.
Yes, ma'am.
Into this study. Okay, good study.
Okay, thank you.
Yes, if there are no queries, can we call upon the next presenter, please?
Priyanka Kumari, are there, ma'am?
Yes, sir.
Okay, we can continue with ma'am. We can share your screen.
Okay, sir.
Yeah, the slide is visible, Priyanka.
Okay, ma'am. Good afternoon to everyone. My name is Priyanka. I am in PhD.
Please increase your volume, Priyanka.
Okay, ma'am. Am I audible, ma'am?
But try to increase your speaker or microphone volume.
Ma'am, am I audible?
Are you using the your voice is not clear.
Little loud, ma'am. Little loud, please.
This is a slide is okay. Your voice, I think you are using our mobile or what?
Yes, ma'am. I'm
So,
using my mobile.
just try to increase your volume and be near to the speaker.
Okay, ma'am. Good afternoon to everyone. My name is Priyanka. I am pursuing my PhD from Punjab Agriculture University, Ludhiana. So the topic for my poster presentation is applications for CRISPR-Cas9 mediated genome editing in vegetable crops. So as we know that the vegetables, they play an important role in human nutrition and health. But there is a lot of losses due to the abiotic and biotic stresses. There is lack of proper storage management and processing facilities, which reduces its production. So from the last many decades, conventional breeding has been contributed significantly for its crop improvement, but they are time consuming and labor intensive. So now the researchers are switching towards the biotechnological tools like genome editing tools. So what is genome editing? So genome editing is the group of technologies which is used to make the precise and specific changes in an organism's genome by using the site-directed nucleases like ZFN, TALEN, CRISPR-Cas9, and some advancements like base and prime editing. So among these genome editing tools, the CRISPR-Cas9 has been found to be most revolutionary among all because of their simplicity, quick operation, higher editing efficiency, and capacity for multiplexing, which means that it can target many genes at the same time. Now, what is CRISPR? So CRISPR is the prokaryotic immune system that protects them from the foreign genetic material like phages, etc. And as we can see in this picture also, it is correct. The CRISPR is characterized by a cluster of repeated there is identical repeats which are interspaced by these non-identical spacers. And the Cas9 is the DNA endonuclease which creates the gene edits. So this CRISPR-Cas9 allows the genetic material to be added, removed, or altered at the specific location in the genome, and hence it is helpful in generating new varieties in vegetable crops. So the main components in this CRISPR-Cas9 is, first one is the single guide RNA, which is composed of two major components, as we can see in this picture also. First one is the CRISPR RNA. This CRISPR RNA is complementary to this target sequence. And second component is the transactivating CRISPR RNA, which is helpful in handling the Cas9 protein. And second main component is the PAM sequence. That is a small sequence which is next to the target sequence, and it is required for Cas9 targeting. Third component is the Cas9 protein, that is the DNA endonuclease that creates the double strand break and at the three base pair upstream of the PAM sequence, and it has two domain. In this picture, we can see in this picture also HNH. First domain is HNH, which cleaves the DNA strand which is complementary to the guide RNA, and other domain is the RUVC, which cuts the DNA which is not complementary to the guide RNA. So after the cleavage, there is the DNA repair mechanism, which includes 2 points. First one is the non-homologous end joining. In this, there is fusion. There is just a simple fusion of the end breaks, and which creates the indels. And this will result in the gene knockout, or we can say that there is the loss of the protein function. And second one is the homology direct repair. In this, the template DNA is used to repair the double strand breaks, and which results in the gene knock-in. Now coming to its application, so it has been successfully used for overcoming the biotic stresses. For example, in tomato, this gene has been targeted for creating the resistance to the powdery mildew, and likewise in cucumber and potato, virus resistance, they get the virus resistant by targeting the following genes. And this has been also used for overcoming the abiotic stresses, like in tomato, drought tolerance is created In pumpkin, salt tolerance, and in lettuce, high temperature tolerance has been created. And it has been also used in for quality improvement, like in tomato. ALC gene has been targeted for creating the long shelf life in tomato. In potato, this STPPO2 has been targeted for reducing the enzymatic browning. Likewise, in carrot, for anthocyanin biosynthesis, and for herbicide resistance also in watermelon. And it has been also successfully used for creating the seedless fruits in tomato by targeting this SIAGL6 gene. So in the conclusion, the CRISPR-Cas9, they can increase the scope of generating vegetable varieties which having the improved quality and biotic and abiotic resistance more quickly than other traditional approaches. But still there are number of challenges, like methods for efficiency delivery strategy and function of gene or genomic information, they are still unknown. And there are also a problem of off targeting. And newly discovered CRISPR techniques like the base editing and prime editing, they are still not much utilized in the vegetable crops. Thank you.
Hope this is a review refresh on CRISPR, isn't it, Priyanka?
Yes, ma'am. This is review.
I think you are pursuing your PhD.
Yes, ma'am. Yes, ma'am.
Then you could have focused something from your MSc, no?
Ma'am, I have presented it.
Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
I think we can move to the next presenter, please.
Okay. Thank you, ma'am.
Shetty, are you there?
No.
Ma'am, are you there?
I think the next presenter is Manasa, Sri Manasa.
Yes, ma'am.
Yeah, please share your screen.
Ma'am, is my slide visible?
Yeah, it is visible.
Shall I start? Hello.
Yes, yes, please.
Good afternoon, everyone. I am S. Sri Manasa, pursuing PhD in Genetics and Plant Breeding at Junagadh Agriculture University. Today, I am here to present you a part of my research work, that is genetic divergence studies in Vigna stipulosia using D-square statistics for fodder purpose. Coming to introduction, we all know that livestock plays a crucial role in rural economy by contributing 6% of total GVA. For their better health and productivity, livestock requires 3 parts of green grass and 1 part of leguminous fodder. But present-day domesticated leguminous fodders are yielding very minimum because they could not cope up with the stresses that occur due to climate change. Besides these domesticated leguminous crops, wild Vigna species, being rich in untapped genetic diversity, have remarkable traits in terms of nutrition, agronomical traits, and biotic and abiotic stress traits. So among these wild Vigna, Vigna stipulosia is an underutilized wild legume, which is also called as mini payalu, was reported as a good source of fodder and stress resistance. So genetic diversity studies of wild Vigna species like Vigna stipulosia will help in providing information which can be used for domesticating wild species or improving cultivated species. So considering this, a study was conducted to assess the genetic diversity present in the Vigna stipulosia genotypes for fodder purpose. Coming to materials and methods, experiment was conducted at Department of Genetics, Plant Breeding, College of Agriculture, Kerala, Agriculture University, by using 30 genotypes of Vigna stipulosia collected from NBPGR New Delhi. And the design adopted was RBD, with 3 replications by adopting a spacing of 30 centimeters into 15 centimeters in a 3 meter square plot size. And these were the observations that were recorded at 50% flowering. Coming to statistical analysis, D-square statistics by opting the method suggested by Mahalanobis 1936 was used. Coming to results and discussion, all the genotypes were grouped into 5 clusters. That a considerable diversity among genotypes is present. Here you can see in table 1, among all the clusters, largest cluster is first cluster with 70 genotypes, and the same have been shown in a dendrogram diagram, figure 1. There cluster 1 was with 17 genotypes and 4th and 5th clusters having single genotypes. Coming to intra and intercluster distances, here in the table 2, diagonal values of table 2 are intra-cluster distances and other are inter-cluster distances. Compared to intra-cluster distances, inter-cluster distances are high. It means that there is a variation among the genomes. Highest intra-cluster distance was observed for cluster 2, that is 13.24. This is implying that it has high variability within the cluster. And highest inter-cluster distance was observed between cluster 2 and 5, that is 25.17. So genotypes of these clusters are highly variable, so can be crossed further to produce transgressive segregants. Coming to cluster means, in the table 3, the cluster means are shown, and for all the traits like secondary branches, leaves, nodes, green fodder, dry fodder, etc. These are the fodder related traits. These were higher for cluster 4 and 5. So genotypes of these clusters can be used for fodder production. Coming to percent contribution, it was found that seed yield per plant followed by leaf stem ratio, internodal length have contributed largely to the total divergence. So finally, coming to the conclusion, grouping of genotypes have shown that 5 clusters are possible, which mean that there is considerable variation, and cluster 2 and 5 showed highest inter-cluster distance. So genotypes of these cluster can be used as parents to exploit heterosis. From cluster mean, as cluster 5 and 4 have high fodder trait means, genotypes of these clusters can be used for fodder production. Finally, from these results, I can tell that Vigna stiplacia can be used for domestication and or can also be used for improving other related Vigna species for fodder purpose. Thank you.
So, is it a wild species or into the stream for fodders, Manasa?
Yes, ma'am.
Is this Vigna stiplacia is a wild species or into already used as a fodder?
Ma'am, actually, it is an underutilized wild species. It is grown in some parts of southern India.
Because it is very new to hear about this Vigna. That's why I was asking.
Yes, ma'am. It is underutilized and it is grown in Karnataka areas and Tamil Nadu areas, ma'am.
Oh. But such species could be tapped because of the lack of green fodder and all. If the field studies could be focused in a scientific way, it would be useful for the farming community, especially in the dry lands.
Yes, ma'am.
Okay. Okay, then. Any more queries from the audience, please? If it is okay, I think the permission to the next person could be given, please.
Monisha ma'am, are you there?
Shall I stop, ma'am?
Monisha has a problem. I think Mr. Suresh can present.
Yes. Mr. Suresh, we can continue with you. And make you co-host, you can share your screen and we can continue.
With these two, we have come to the end of the poster presentation, sir, or still anyone is pending?
No, ma'am, there is like no participants are pending. No, Suresh, you're not audible.
Yeah, Suresh, you could present, please.
Yes, sir.
Yeah, you are not audible now. You can continue.
Good afternoon to all. Sir,
Yeah, good afternoon,
my
Suresh.
screen is visible?
Yes.
Yes,
Continue.
visible and audible, please.
First of all, good afternoon to all. I am Suresh, PhD research scholar. My department is agricultural meteorology. I am doing PhD in Forest Jhansi, Haryana Agriculture University, Hisar. My research topic is evaluation of hello.
Yes, please. You are audible, Suresh. Mr. Suresh, please go ahead.
Yes, ma'am. I think there is intense learning.
You can go ahead.
Yes,
Please.
yes. My topic is assessment the spatio-temporal climatic variability during the 3-decade wheat cultivation period in Haryana. Let's start from introduction. The wheat, uh, mm, the scientifically known as Triticum st1, belong to Gramineae family, having a major role in India's agriculture. Uh, as India ranked third in wheat production, as well as if we talk about Haryana, Haryana is also under fourth rank for wheat production. Annually share 10% of production area. Uh, if we talk about objective, these are my objective: assessment of location-based and time-based climatic variability of wheat crop in Haryana, and this is the analysis of 3-decadal climatological parameter impact over production of wheat in Haryana, and the comparison of climatological weather parameter impact through GIS maps. These are the objective. So if we talk about methodology in my research, we have collected the secondary data up to 2020 from 1990 of 30 years of wheat productivity from statistical aspect of Haryana, and long-term climatic weather data like maximum temperature, minimum temperature, rainfall. We have collected from Department Agriculture Meteorology, and for compute the climatological variability, we have used the statistical measure like the standard deviation coefficient of variation from 1990 to 2020. For this, let's come to result and discussion. In the 30-year secondary data analysis, we have find we have four analysis parameter: average and maximum degree Celsius, average annual temperature, average annual rainfall in, and annual wheat area and production of Haryana 1990 to 2090. So if we talk about conclusion, the study highlights the adverse impact of climate change on wheat yield, especially due to temperature fluctuation during various growth stage, and in this warmer temperature shorten vegetable crop duration, resulting in sparse drilling, poor growth, and premature heading during the early vegetation phase, and forcing to maturity during grain filling lead to low yield. If we discuss about conclusion, the maximum temperature 1920, the Panchkula and the Yamunanagar district recorded lowest average annual maximum temperature below 28 degrees Celsius, and likewise Bhiwani, Charkhi Dadri, Mahendragarh, these are the higher side of degree Celsius temperature, 32 degrees Celsius average annual temperature, and rest of the districts lies between 29 to 30 degrees Celsius temperature. If we talk about annual minimum temperature, so majority of the districts lies below lies above 18 degrees Celsius, like western zone of Haryana districts Karnal, Fatehbad, Sirsa, Hisar, Jeend, Panipat. These districts show higher temperature as compared to eastern climatic zone. From this study, we also conclude among all districts, Panchkula and Yamunanagar had the lowest average annual maximum temperature at 28 degrees Celsius over the 30-year
Suresh, I
period.
think you can conclude, please.
Yes, ma'am. From 30 year of data analysis, we have concluded that an inverse relationship between air temperature and wheat yield was observed, indicating the higher temperature during the growing season lead to lead to a lower yield. These are the conclusion about maximum temperature and minimum temperature. And if we talk about annual rainfall, so in eastern part of the Haryana, the Panchkula, Ambala, and Karnal districts record highest number of average annual rainfall, 600 to 900 mm, while Kurukshetra, Kathal, these having average rainfall 300 to 600 minimum, and the western areas like Sirsa, Fatehpur recorded lowest mm of rainfall. So if we talk about future
Okay.
plan about this,
Yes, only it is on temperature and anything about pest and disease incidents with respect to these temperatures?
Yes, madam.
Pest and disease.
Pest and disease. No, madam. I have took only one parameter.
Oh.
Yes,
yield versus this parameters were done or
yes,
only
yes.
those stages?
Yield versus madam only climatological parameter like average annual time.
How much yield reduction was maximum when the temperatures range was like that? Any point could be focused?
Yes, madam. If temperature average maximum temperature increases from 5 to 10 degrees, then there is reduction of yield, madam. Or particular in the
At what growth stage or critical stage? In that way, if it could be concluded, it is better.
yes, on madam. We can heat if temperature is higher, then this lead to premature heading and which lead to forced maturity and lead to low yield.
Okay then. Okay.
Yes,
any queries from the audience? If not, the next participant can please present. Okay, Suresh, all the best.
Thank you.
But you can be next participant.
Sir, am I audible?
Yes, Monisha.
Yeah, Monisha, you are audible. Please share your screen.
Is my screen visible?
Yes, yes. Continue.
Good afternoon, everyone. Myself, Monisha T, PhD scholar of Department of Vegetable Science from Punjab Agriculture University. The topic of my poster presentation is a review on RNA interference for improving disease resistance in vegetable crops. So, as it is well known that eating vegetables every day is important for human health. They provide essential nutrients, minerals, and nutrients which are important to raise our energy levels. So, due to increased growth of population rate and decreased availability of cultivation, it is essential to improve the production and productivity of vegetables. In this crucial era, There is a down in production due to the attack of various biotic and abiotic stresses. Previously, traditional breeding techniques were applied to develop resistance to various diseases in cultivars, but these techniques are very time consuming. So now there are many novel biotechnological approaches developed to fight with these variable crop pathogens. One among those is RNAi, which is making good progress and offering a possible alternative for genetic transformation by combating biotic stresses in plants. So RNAi usually it knocks down the gene, that is gene silencing, by interrupting or suppressing the expression of a gene at transcriptional level, that is called as mRNA degradation, or at post transcriptional level, that is there will be no production of protein. So how does RNAi work? Every organism has some super specific defense mechanism, including human beings. What they'll do, like it takes care of all the troublemaking RNAs, like viral RNAs, in humans like cancer inducing RNAs. So nowadays we use RNAi to study genes by understanding its gene function, and to control pests and also to cure diseases. So, how are we going to use this RNAi in controlling diseases? Firstly, the viral DNA, the part of the viral DNA has taken, and that part is cloned, and that is transferred into the host plant with a bacterium called Agrobacterium tumefaciens. And now the gene is integrated into the plant's genome, that is double stranded DNA. So, each of these strands undergo transcription and produce new mRNA, and these mRNA strands produce complementary strands, and then either it can stay as it is or it breaks down into small RNAs. So now it will end up ingesting small RNAs, and the plant's RNA interference machinery kicks in. So now it tries to find out the mRNA which is complementary to these small RNAs, and then it will slice that mRNA. So at last, targeted essential protein will not be translated and the disease will not survive. That's how RNA mechanism shut down the essential protein. So now a question arises: plants RNA interference machinery will stop there? No. Whenever disease enters, it will restart. That is, the RNA interference mechanism kicks in. So here the RNA interference takes place by two types of small RNAs. One is microRNA and another one is small interfering RNAs. So these RNAs are similar to proteins, and microRNA, they are present in the nucleus. Each gene is transcribed by the RNA polymerase, and it produces the primary microRNA with stem loop structure and two tails. Now the DROSA, an enzyme, will involve, and it will cut down the tails, and it will produce precursor microRNA, and this precursor microRNA is transported to cytoplasm with the enzyme called exportin 5. Now this is recognized by a large RNase protein called dicer, and it leaves the stem loop and forms a small double-stranded microRNA and the siRNA, which is exogenously introduced into the plant cell. And now it leaves the stem loop structure and forms a small microRNA and siRNA. And then the argonauts protein, that is AGO complex, interacts with the dicer to bind the miRNA. Now miRNA unwinds and one strand is released. The released strand is called passenger strand, and the remaining strand called guide strand interacts with the argonate protein to form a complex. That complex is called as RISC, which is RNA induced silencing complex. Now it is guided to target mRNA to inactivate the genes, that is mRNA of the target gene. Now it enables base pairing, and once bound, there are two ways in which RISC can inactivate the mRNA. One is the proteins in the complex can simply cut the mRNA, which will be further destroyed by the cell. And the second is inhibition of translation. In both the cases, mRNA does not get translated, and at last gene is silenced. So there are two strategies employed to exploit the RNA mechanism for controlling plant pathogens. One is host induced gene silencing. This is GMO method, that is Agrobacterium mediated tumefaciens. Through that, gene silencing happens. And another one is spray induced gene silencing, which is non GMO and effective only for few weeks. So in whole, there are many successful studies applied by host induced gene silencing, and they control the diseases like African cassava mosaic virus, all those are in vegetables, and potato virus Y, fusarium wilt, and begomo virus. Whereas in case of spray induced gene silencing, pea seed-borne mosaic virus, fusarium crown and root rot, late blight, and gray mold has been successfully silenced. And I'm concluding this by saying RNA interference offers several applications other than the resistance to diseases, which includes fruit improvement, that is, it enhances the nutritional value of the crop, shelf life, and also development of seedless fruit, reduction of undesirable components, and the development of biotic and abiotic stresses. So, therefore, RNAi can be suggested as a novel, powerful technology having revolutionary capabilities that could be further exploited for functional study of target genes and regulation of expression for the enhancement of vegetable crops. Thank you.
So this is a review, isn't it, Monisha?
Yes, ma'am. It is a review, ma'am.
So PhD, you are pursuing PhD and still you are presenting review, huh?
I have already presented my research papers, and this is my credit seminar, so I wanted to present it.
I think we can go for the last participant.
Sir, am I audible?
Yes, yes, yes.
Good morning to all present here. My name is Akshay Kumar Walia, and I am doing my PhD from Dr. Y.S. University of Horticulture and Forestry, and this is my research poster on the topic influence of doses and time durations for seed priming with zinc oxide nanoparticles on germination and vigor of okra. We all know that okra is one of the most important crop in the country, which has an area of 3.1 lakh hectares and production of 64 lakh metric tons. Generally, okra shows reduced field emergence due to hard seed coat, which hinders with its weed management, harvesting, and handling practices. Due to this, seed priming is one of the method which is used to improve the germination of the crops. Coupled with it, we use zinc oxide nanoparticles, which act as biostimulant and stress remedies, enhancing germination, seed growth, and plant well-being. Seed nanopriming with zinc oxide nanoparticles improve nutrient uptake, antioxidants, and reduces the ROS accumulation. The main objective of the study was to seek to optimize the appropriate dosage for zinc oxide nanoparticles to enhance germination, vigor, and seed quality of okra. The research was done at Dr. Vice Verma University of Horticulture and Forestry with variety P8, and the nanoparticle solutions were prepared by weighing different amounts of nanopowders and adding them in deionized water, then stirring them for 5 minutes, and followed by dispersion in water bath under ultrasonic treatment for 30 minutes. Seeds were first surface sterilized and then primed with different concentration of nanoparticles, and then they were placed in roll tower to measure the seed quality parameters. And the analysis was done. The data on germination, vigor, and seed quality of okra cultivar P8 is given in the table. Here we can see that seed priming with zinc oxide nanoparticles at 100 ppm, 150 ppm concentration for 18 hours showed the best results for germination, shoot length, root length, seedling dry weight, seedling vigor index 1, 2, and germination after accelerated aging. Where SVI1 is the seed vigor index 1, SVI2 shows the seed vigor index 2, and AAT means germination percentage after accelerated aging. The conclusion of the study revealed that zinc oxide nanoparticle seed priming at 150 ppm concentration for 18 hours improved germination, seedling length, seedling dry weight, shoot and root length, and other quality attributes of okra. Thank you.
So, is it on yield, its effect was not seen?
I can't hear, pardon, ma'am.
Yield parameters, you did not.
Ma'am, this is just the one part of my study. I have done field trial also.
Lab study.
This is lab study for just knowing the effect of nanopriming on quality of okra seeds. And after that, I have also done that physiological studies and field studies, but it is not added in this.
Because it's okay, but I think
and there is considerable increase in yield also.
Yeah, most of the studies are only up to seedling and germination.
Yeah, no, ma'am, I have taken them to field also.
Yeah. If something on yield, then it will have some positive effect.
Okay, ma'am.
Otherwise, farmers generally are more interested in the yield and all.
Okay, ma'am.
Okay. Okay, then all the best.
Thank you, ma'am.
So I hope this is someone has posted Kalpana.
Yeah, ma'am, I think.
Yes, ma'am.
I think, okay, then Kalpana, I think you can please share your screen.
Ma'am, am I audible?
Yes,
Hello.
yes.
Yes, please, audible and visible.
Good morning, everyone. My name is Kalpana Yadav. I am a PhD research scholar at CCS HAU Hisar. My topic of my presentation is tomato grafting, offering nematode and fusarium wilt resistance under protected cultivation. So, as we know, vegetable grafting is the union of two different plants or parts where we unite the or graft the scion on the rootstock and that later grow as an individual plant where cyan is the above ground part that is used for food production and quality, while rootstock is the below ground part that offers resistance to different biotic stresses like nematodes, wilt fungus, or many other soil-borne pathogens. So, as we know, root knot nematodes and fusarium wilt are major biotic stresses that affect tomato production and fruit quality under greenhouses as well as in open fields and cause up to 40 to 60% losses. So to combat these stresses without the use of chemicals, we have planned the research work using the vegetable grafting. So objective of my research to firstly we have screened the different brinjal and tomato rootstock for resistance against fusarium nematode wilt complex, and these rootstocks were also pre-screened in different experiments against root knot nematodes. And about among these rootstocks, we have taken two most significant which gave the better results. We have choose two rootstocks. We have also evaluated the grafted tomatoes for growth, yield, and quality characters under fusarium nematode infested condition, and we have also studied the physiobiochemical responses in grafted plants. So we have used the splice grafting method. So in results, we have seen that roots for the average fruit yield per plant, the effect of rootstock was significant, and among the grafting combinations, the grafted plants on rootstock 1 and rootstock 2, the rootstock 1 was Solanum torvon and rootstock 2 was the wild accession from Rajasthan. They gave the better results over non-grafted plants, and for the quality parameters like TSS, ascorbic acid, so in TSS also the grafted plants were better over non-grafted plants. And if we talk about the crop duration, so that was the most significant thing. In grafted plants, we have increased the crop duration about 15 to 27 days over non-grafted plants. And the phenol contents on the peroxidases was also higher in the grafted plant. So we can say that the chosen rootstocks are rootstock 1 and rootstock 2 can be used for the grafting for further studies and can also be used by the farmers. And the Pusa Ruby, Punjab Gaurav and Himsona can be used as cyan. So we can say the grafting is a chemical-free method for nematode fusarium wilt resistance in protected cultivation, and it can be increase the yield about 14 to 18% in grafted tomato plants. Also improve the quality like TSS and ascorbic acid, and the higher phenol content was observed in the grafted plants over non-grafted, and also the nematode population buildup that reduced by 40 to 60% in infested polyhouses by growing grafted tomato plants. And the fusarium wilt incidence was also lower, and the severity of the disease was also lower in the grafted plants over non-grafted. So we can say the grafting is the eco-friendly solution for nematode and fusarium resistance in protected cultivation with improved yield and quality. Thank you.
This was conducted under protected cultivation now, Kalpana.
Ma'am, we have screened those in screen houses, and at that time we used the poly cover, ma'am, during winter, not properly in the poly houses.
So was this particular thing again? Went to the farmers for their field conditions and all. This technique.
No, ma'am. Now we are doing research. We have not sent this technique to farmers yet. Our trial are going on. We are under third year of the trials.
Then I think it would be a good result if it is successful and
Yes,
consistently giving a good result.
Yes, ma'am.
How serious is this problem in your area, especially Fusarium wilt and nematode?
Ma'am, mainly there is no proper solution for the chemical solution for nematode and fusarium wilt in the polyhouses. So farmers are avoiding the use of polyhouses and they are less motivating towards the polyhouses. So we can give them a technique that can increase their yield. So we can motivate by vegetable grafting.
What is the yield reduction due to this nematode and Fusarium wilt in this particular tomato?
Ma'am, about 40 to 60% reduction according to different studies. Some studies shows 35% mainly.
Because in our regions, I think nematode is a less, but Fusarium wilt is a common one.
Yes, ma'am. Also in open field condition, ma'am, we can use these grafted vegetables in open field also.
Even competition is also one of the technique which we can follow instead of going for continuously sensitive crops.
Sorry, ma'am, please pardon.
Crop rotation with other
Yes,
crops.
ma'am. Yes, ma'am. Also other things we can use in open field. Crop rotation, yes. Also soil solarization in polyhouses.
Okay, then good presentation. It is based on your research study. No?
Yes, ma'am. Yes, ma'am.
I think this ends the session. Okay, all the best, Kalpana, for your future endeavors.
Thank you, ma'am.
You can log. Yes, sir. I think still anyone is there to present. I hope. Still anyone there, sir?
No, ma'am, I don't think there's any.
Can we end the session then? Shall we close the session?
Yes, ma'am.
So, okay. Then, you
Please
can
join it.
give the announcement, madam, to the audience when to join for the valedictory session.
Please join at 3:30 for the valedictory session.
So, same link, no, madam? What has
Yes,
been
ma'am. Same link.
today, whatever is given. And I think in the last link is continuing from the first day. Same link.
Yes, yes, ma'am. Same link is continuing, ma'am.
So, 3:30 we can join.
Yes, ma'am.
Madam, I think actually we are in office now. We will be leaving to the house. I think we can join through our mobile now, madam, for the valedictory, not an issue.
Yes, ma'am. That will not be an issue.
Because all the technical sessions have been completed.
Yes, ma'am.
Yeah. One more doubt, madam. We have sent the abstracts till yesterday. I think all will be considered for printing into the souvenir, no, madam, till yesterday.
Yes, ma'am. All will be considered.
And the manuscript is not needed because full length manuscript also you asked, we have sent actually through mail.
You have sent full length also, ma'am?
I mean, manuscript you wanted, no, madam, 5 to 6 pages manuscript. So we have
No,
sent
manuscript is not needed, ma'am.
Then abstract yesterday, one more we have sent yesterday itself. So do consider.
I'll check, ma'am.
Okay. Okay, madam. Thank you very much. Then we'll join by 3:30, all of us.
Okay, ma'am.
Okay, thank you.
रोहित क्या हुआ, अचानक से शांति क्यों हो गई इतनी, क्या हुआ?
सर चले गए मैम, I think
सब चले गए?
एक पार्टिसिपेंट रह गया सर लास्ट
एक पार्टिसिपेंट, तो उनका भी कराओ, फिर वैलिडिटी का तैयारी करनी है भाई।
ठीक है सर। रेनू, are you there? रेनू, Renu, are you there? Or you can unmute yourself.
Yes, sir.
You can share your screen, then we can continue with you.
Okay, sir. Okay, sir. Is my screen visible, sir?
Not yet.
Second, sir. Now my screen is visible, sir.
Continue, please continue.
Good afternoon to all of you respected members. I am Renu Fandan from CCS HAU Hisar from the Department of Vegetable Science. Today I am here to deliver my poster presentation with title Evaluation of GCV, PCV, Heritability and Genetic Advance in Different Okra Genotypes. First of all, introduction. Okra, locally known as bhindi, belongs to the Malvaceae family. It is allotetraploid and autogamous species. It is predominantly a self-pollinating, but also cross-pollination occur here. It is rich source of carbohydrate, protein, and fiber, and its seed contain oil content 20 to 40%. First of all, we have to discuss about GCV and PCV. Standard deviation divided by mean is the genotypic coefficient of variation and phenotypic coefficient of variation. If GCV value is lower than the PCV value, then the mainly environmental effect is seen. That means the overall phenotypic effect is seen in the trait of a plant. Heritability is the heritable portion of phenotypic variation, or it is the transmissibility of character from parents to offspring. Genetic advance denote an increase in the mean genotypic value of selected families over the base population, allowing the breeder to select progenies in the previous generation. Now we have to discuss about the material and methods. The experiment is conducted at CCS HAU Hisar Vegetable Science Research Farm. 30 genotypes of okra were taken, and different observations are taken, like plant height, branches per plant, etc. And genotypic and phenotypic coefficient of variation calculated by the formula or the given by Burton. Next, the results of the experiment concludes that the higher value of GCV, PCV, heritability, etc. are observed for plant height, and moderate value of GCV, PCV, heritability and genetic advance observed for the fruits per plant or the yield per plant. That means the high value of GCV, PCV, heritability or genetic advance show that the characters are highly heritable, and they can be used for improvement in the further breeding programs. The results or the conclusion of my experiment is that there is significant variability exists within the selected genotypes, which could be positively exploited in crop improvement programs. From the 30 genotypes, HB69108, HBT491, the variety Hisar Unnat, the variety Hisar Naveen, and the genotype HBTC671, Varsa Ukhar, and Arka Abhay were superior for overall yield and yield attributing characters, and these genotypes can be used for improving or used in further breeding programs for improvement. Thank you, sir.
Thank you so much, Renu. Thank you. अंकु सर अभी क्लोज करें?
हेलो,
हाँ जी सर।
यदि किसी का कोई क्वेश्चन है तो पूछिए आप। मैडम भानुरेखा है? चरण सिंह साहब, विकास जी। ये रिसर्च आपके द्वारा ही करी गई है ना?
यस सर।
और ये जो जीसीबी और पीसीबी लिखे हो, इसका एब्रिविएशन जो है, इसका फुल फॉर्म क्या होता है?
जीनोटिपिक कोफिशिएंट ऑफ वेरिएशन एंड फिनोटिपिक कोफिशिएंट ऑफ वेरिएशन सर।
और ओकरा में कितने क्रोमोसोम्स पाए जाते हैं?
Okra is a allotetraploid species सर, 74 to 115 और 164 तक सर इसमें क्रोमोसोम होते हैं सर।
अच्छा, दो हाई यील्डिंग वेराइटीज बताओगे मुझे?
हाई यील्डिंग वैरायटीज में सर जो मेरा एक्सपेरिमेंट था उसके अकॉर्डिंग सर वर्षा उपहार थी, हिसार उन्नत, हिसार नवीन एंड एक जीनोटाइप था सर HB69108 सर। HBT 491
समर सीजन ओकरा और रेनी सीजन ओकरा के सीड रेट में क्या डिफरेंस?
सर रेनी सीजन ओकरा में कम सीड रेट यूज करते हैं और समर में ज्यादा करते हैं सर, बिकॉज इट्स जो सीड कोट होती है सर वो हार्ड होती है सर। तो देर इज जर्मिनेशन प्रॉब्लम सर।
अच्छा,
यस
कभी
सर।
आपने ये देखा होगा कि अगर हमने ओकरा को कट किया तो कट
यस सर।
करने के बाद उसमें एक गमी सब्सटेंसेस दिखता है जो चिपकता है हाथों में। ये किसके
यस।
कारण होता है? एक उसमें पाया जाता है एंजाइम, क्या होता है? ये कंपटीशन का क्वेश्चन है, इसको नोट कर लेना। म्यूसिलेज एक होता है उसमें, म्यूसिलेज के कारण उसमें चिपचिपाहट होती है। ये क्वेश्चन पूछा
यस
जाता है पैनल्स में। ठीक है,
सर।
चलो, वैसे बहुत बढ़िया रहा आपका, मेरी शुभकामनाएं। यदि
थैंक यू
कोई
सर।
और पूछना चाहता है, कोई क्वेश्चन हो, नहीं तो हम नेक्स्ट के लिए प्रोसीड करें। चलिए, बहुत बढ़िया है ना, मेरी शुभकामनाएं।
थैंक
जी,
यू सर।
ठीक है। रोहित जी, कोई नेक्स्ट है?
नो सर, नो सर।
चलो, तो इसका मतलब पोस्टर और ओरल जो थे अपने वो सब निबट गए,
हाँ, दोनों कंप्लीट
है ना? आप सुन पा रहे हैं रोहित जी?
जी सर, जी सर, दोनों कंप्लीट हो गए
पोस्टर और ओरल जो हमारे थे वो दोनों निबट गए।
यस सर, यस सर।
चलो, अब 3:30 पे मिलते हैं वैलिडिटरी सेशन में।
जी सर।
उसके लिए तैयारी करनी है बड़ा अच्छे से, ठीक है?
जी सर।
चलो, ठीक है, ओके।